Up at night, yeah. Make all the demons quiet, yeah. We were built to thrive, yeah. I think that we've all had enough. What keeps you up at night, yeah. Make all the demons quiet, yeah. We were built to thrive, yeah. I think that we've all had enough. Yeah, I think that we've all had enough. Sick and tired with the old plan. They know that we're calling it wrong. You got me like, oh yeah. I think that we've all had enough. They know that we're calling it wrong. Hey, it's too late to try to go contain it. A generation fueled by creation. We live lives on a small screen nation. We control the airwaves, no negotiation. I refuse to think we need saving. Something good will come from creation. And when we think that the world is too anxious, we'll adapt, evolve, survive, and save it. What keeps you up at night, yeah. Make all the demons quiet, yeah. We were built to thrive, yeah. I think that we've all had enough. What keeps you up at night, yeah. Make all the demons quiet, yeah. We were built to thrive, yeah. I think that we've all had enough. Yeah, I think that we've all had enough. Sick of dealing with the old plan. They know that we're calling it wrong. You got me like, oh yeah. I think that we've all had enough. Sick of dealing with the old plan. They know that we're calling it wrong. Hey.
Good evening and welcome to Sovereign Soul Unchained Mind. I know this is kind of like an unscheduled situation. We're going to have a guest here from Twitter that I ran across today. There was, the people are wondering what's the debate about. Well, what I like to do is I go on to some of these social medias like Twitter, and I think it's really amazing. I thought I hadn't done it in quite a while, so I was going to give it a try after a few years of it's interesting that if you put out anything about certain subjects, God, flat earth, evolution, it's like it's almost the same Agent Smiths come out from everywhere to, oh no, that can't be true. And they really, a lot of times engage in the ad hominem. And I guess my guest is against that as well, using the ad hominem, because that was one of the conditions of talking about this. The way it was described to me was that I would be destroyed in a debate, and I'm really not understanding what is meant by that. It was my understanding that a debate is a rational discussion of opposing opinions and ideas, and that the listener is the one, those that are viewing the debate are the ones that come about with their own consensus based on what they've been presented with. I do see, however, many times these things devolve into arguments, whereas tempers start to flare. We're going to keep this very calm. We're not going to engage in ad hominems. We are only going to engage in things that we can 100% prove. And by proof, that means it has to pass the gold standard of science. As soon as an assumption is brought in, there is no more gold standard involved. Now we're dealing with fantasy stuff. So that would sort of like be jumping in to describe what the flowers look like in Narnia before we have even determined that Narnia exists, if you can get that. So my guest is Red from Reds Rhetoric on Twitter. I guess you can follow him there. We kind of set this up at the last minute. He said that he could be ready at a short period of time, and I said, let's get this, let's do this. I would love to do it because I think the more informed people can be on both sides of the argument, the better off we are. I do find, and it doesn't seem that way in Red's case, but I do find that in a lot of cases, a lot of people that want to argue and get angry about it don't really know much about what they supposedly believe in the first place. They just do because it's the thing. It's what everybody does. It's what we were told, that kind of thing. And you know what we do here? We question everything. So I'd like to welcome Red. Red, how are you doing this evening?
Doing fine. Minor correction. I didn't say that you would be destroyed in the debate. That was actually in regards
I didn't say you said that. I didn't say you said that. There was a lot of comments and stuff that in that thread that I was looking in my notifications, and there was a whole bunch of stuff in there. This guy's going to destroy you. And I'm like, what does that even mean? You know, it's not about being destroyed. It's about presenting the ideas and the facts. And that's what a debate actually is.
It's a metaphor. But anyway,
Right.
so long as that, let's just call that, so long as that image isn't at the forefront of people's minds, because again, I didn't say anything about destroying you personally.
Right,
if anything, that was for someone else. So now that that's been cleared up, we can continue.
Where are you coming to us from, Red, if you don't mind me asking? I'm in the Shenandoah Valley of Virginia.
Tampa, Florida.
Tampa, Florida. I've been there. It's beautiful, beautiful down here. And it looks like your state's getting more and more free while the rest of us are getting more and more enslaved. Look,
sure.
I mean, it's that's anyway, that's the rhetoric that I get in the local media. So I'd like to start this out that the claim, I would say that extraordinary claims require absolute proofs. And one of the extraordinary claims is that the Earth is a globe. Now, we first have to start there because this is what it all hinges on. So why do we determine that the Earth is a globe?
Because of the impossibility to the contrary.
What impossibility would be of that? Why would that be an impossibility?
Specifically.
Why? Well, I explain. Why would that be an impossibility?
Do you know when Equatorial?
For it not to be a globe. I'm sorry, I didn't mean to talk over you. There's a little delay. But I'm saying in order for it to be a globe, why would it be impossible for it to be anything else?
Do you know what an equatorial telescope mount is?
Yeah.
All right. The fact that the equatorial telescope mount works shows the geometric impossibility of a flat Earth.
Not
in order for the flat Earth to be true, an equatorial telescope mount would have to operate by moving more than one axis at a time. However, in reality, we only need to move we only need to move one axis of rotation in order to track any celestial object. Now, if you were to model this out as I did on my YouTube channel, and I have a video here ready to rock and roll, if you would allow, you would see a clear example that in order for the flat Earth to be true, then the operation of an equatorial telescope mount would have to fundamentally change. The fact that it doesn't operate like that in reality shows that reality disagrees with the notion that the Earth is flat. That's just the first piece of evidence that I have. I will go ahead and
present. Can I address that evidence? Can I address that before we just go any further? Would that be affected if there was a lens between the telescope and what you're looking at?
What lens?
For instance, what if there were the containment that holds our atmosphere in?
There's a containment that holds our atmosphere in?
There would absolutely have to be. You cannot have a gas pressure system within a vacuum or a lower pressure system without containment.
Well, here's the thing. I believe by containment, you mean the idea of a physical dome.
Yeah, there is no dome. There would have to be some physical barrier. There is
no physical barrier. And the reason why we know this is because when rockets launch, we don't see them colliding into any physical object.
No, we see them curve off into the horizon, and then we see them come on TV and tell us that they're out in space.
No, we actually have evidence to show that they're in space, but we'll get back to that in a moment. Let me show you this. Let me mute the audio because I don't want you to get dinged with a copyright.
Right.
So this is a flat Earth model, much like I see plastered on the back wall of your room in some of your previous videos. Here we see it tracking a celestial object. You'll notice the two axes of rotation. Here's the first axis of rotation within this model. As you can see, it is moving. Here is the second axis of rotation on this model. As you can see, it is moving. By the movement of two of these axes, we see that the flat Earth model fails to comport with reality. Now, if I were to fast forward to the globe model, so we are tracking, again, another celestial object using the same exact equatorial mount. And as you can see, it is able to track it on the globe model. Here's the first axis of rotation. As you can see, it is staying still as it does in reality. And if we look at the second axis of rotation, we can see that it moves as it does in reality. And the reason why we know this for a fact, and the reason why this passes the test, is because I start the video off by showing an equatorial telescope mount tracking celestial objects as they do in reality while only rotating one axis. Therefore, the flat Earth model, in order for that to be the case, it would have to fundamentally change the operation of this mount, but geometrically speaking, it doesn't work with the flat Earth.
You're following objects in the sky and determining that the Earth is moving?
I didn't say anything about the Earth moving.
Well, I mean that's what I'm saying. Right. Yeah, absolutely. So how are the stars if they're going by? Okay, they're going by. The Earth is actually rotating, so that's why the stars appear like they're going away and moving in the sky. Is that what
I'm not talking about the movement of the Earth, sir. I'm talking about the shape.
I kind of am going with that because of the fact that you were using these celestial objects in order to prove the sphericity of the Earth in conjunction with the movement of a telescope.
Remember the original model that I showed. The original model that I showed, the one that flat earthers would agree with, is the way the celestial bodies move. The flat Earth was not moving in that model. The celestial object was.
Put it back to that point. Put it back to that point where you're saying what flat earthers believe star movement is, because that could very well be an assumption. You don't know that that's how everybody thinks that it is. That's how you think that we think it is.
No, it's not. It's not whether or not I think it seems
like the difference. It seems like the difference in what we're saying. I'm saying that we're looking through a curved lens. You're saying we're looking at it on a curved platform.
No. You misunderstand my point. My point is that it doesn't matter if the sphere is rotating or being rotated around by something else. It doesn't matter if we're talking about heliocentric versus geocentric. The geometric consequences of the equatorial telescope out working as it does in reality is the exact same. That consequence being that the flat Earth model does not comport with reality.
Hang on a sec here. I just want to bring this up real quick. Let me pull this back. Just for food for thought as we talk. As you can see, we are basically talking about that same thing, but why don't we go ahead and if that's it, that you can, because you have to move a telescope a certain degree as the stars move in the sky in order to track them, is proof of a globe?
No, I didn't say it had to move by a certain degree, sir. I said it has a number of axes of rotation. The flat Earth model requires the movement of two, while reality only requires the movement of one. When you compare these two facts against each other, then you ask yourself, what model best comports with what I'm observing with the equatorial telescope mount? We find that the round Earth model best comports with what I'm observing with the equatorial telescope mount.
Okay, so why can't we just go ahead and measure the sphericity of the Earth itself? I mean, it's only what, 24,000 miles in circumference?
You can also do it with an equatorial telescope mount, but now telescopes have didn't
they determine this already before they had this equatorial mount telescope?
Sure, the nameless faceless did, but I'm talking
that's relatively new, isn't it?
No, I'm not making that suggestion at all. What I'm saying is that we don't have to take anyone else's word for it. What we can actually do is using modern equipment, which modern telescopes actually have the capability of making these measurements. If you were to travel, there's a road in Florida that if you were to travel up by a certain amount, you would actually see the stars in the sky relative to North Celestial Pole, I'll say, shift by a like a half a degree, I think. That half a degree is actually detectable with modern day telescopes. That modern day telescope equipment that anyone can purchase will actually allow you to measure the circumference of the Earth.
Well, is it measuring the circumference of the Earth, or there again, the curvature of the dome itself?
Yeah, but there is no dome.
Well, wait a second. We haven't determined that. We haven't determined that yet. We're still we're going to get to that. We're going to get to that. Believe me. What I'm getting at is you have no way to prove these distances of vast distances of these stars. This is what it all hinges on. This is what it all hinges on.
I didn't make any claim.
No, I know you're not. I know, but this whole thing would depend on that as well. You just claim that there's no containment, whereas physics and science dictates that there must be containment. There must be containment. The pressure cannot be. You've got 14.7 psi at sea level, and the dead of space, or even just close to the moon. Okay, the moon, they said, is 10 to the negative 11 torr. For those of you that want to know what that is in psi, it's a negative 2 billion psi. So basically a full fucking vacuum.
There's no such thing as negative psi, but okay.
That's what the scientists tell us, is that it's 10 to the negative 11 torr is the pressure, or negative.
Just a quick question. Do you think a negative exponent makes it a negative number?
Dude, I'm using your guys' numbers. That ain't my number. I don't think that exists at all. I don't think it exists at all. I'm using the number that your NASA scientists and your astrophysicists use.
But if you don't understand what they're talking about, then how can you properly decipher what they're telling you? So
it's the absence of positive pressure. The bottom line is this. The bottom line is this, Red. You cannot have a negative pressure system next to a positive pressure system without containment, or equalization will take place. Nature abhors a vacuum.
I go back to my original question. Do you believe that a negative exponent on a number makes that number negative?
I'm just telling you what the fucking number that your people give us. What is it then? What is the number? What is the pressure of space? What is the pressure? Hold on, Red. What is the pressure of space?
It makes it a decimal point, not a negative number. So for you to say that NASA is claiming that they're asserting negative PSI means you fundamentally do not understand what NASA's been telling you. So this entire time, you've been arguing
10 to the negative 11. Okay, well, you tell me what the pressure of space is then, Red. What is the pressure of space? Is it less? Is it less or more than it is on Earth?
Oh, it's much less.
Much less. So you want to tell me how that keeps from equalization? That's a vast area of no pressure against a small amount of pressure.
Do you believe
how in the world does that not equalize if there's no containment?
All right, let's go ahead and
can you prove that this can occur?
Yes, I can.
How?
Just like
show me an experiment. Show me an experiment where you've got a ball of compressed gas without any containment.
No, I'll give you an observation, just as empirical. Would you agree?
No. Well, okay. Let me hear what the observation is.
Are empirical? Are you fucking?
All right, go ahead. Go with it. Go ahead.
Okay.
Don't start with that shit. Are you this or are you that? Don't start with that. We're not going there. We're not doing tempers here. We don't do tempers here. This is the continental. Okay, like in John Wick, we don't do that here.
The continental asserts that. Okay, whatever. Anyway, observations are empirical.
Cool. Right? What's the observation?
All right, perfect. So there is a rocket called the Atlas 5551. I was able to record one back in 2018. This is a luminous launch. And so let me go ahead and show you this.
Mm-hmm.
Sir, would you please allow my screen share?
Oh, yeah, I'm sorry. I didn't see it down there. My bad. Wait, I had mine on there. There we go.
Okay. Now, we would agree that if I had a packet of gas in a vacuum chamber and I were to split that packet open, the gas would expand to fill the void, correct?
That's correct.
All right, perfect. We're in agreement there. We're in agreement there. We're good. Okay. So as the rocket gets higher and higher and higher, it eventually crosses a boundary at this particular time in the morning. Now,
are you talking about the Kármán line?
No. I'm not talking about that boundary. I'll explain as the video goes. Now, this, am my audio muted? I heard some bells. Anyway, so as you can see by this rocket, this is the boundary it crosses. See what happened? The gases are becoming illuminated, which means, yeah, the gases became illuminated. The reason why that is, just so that your viewers understand what's going on here, is that the rocket has got high enough during the early morning hours to see over the curve of the Earth and be illuminated by the sunshine. That's not the proof that I'm wanting to show here, but that's just what's going on here so people can understand why the gases are glowing. At this altitude, the gases are contained.
What altitude is that? Here. What altitude is that, and what verification of that altitude do you have?
Well, we'll get back to that in a moment. Let me just
I'm looking and I see a fucking streak in the sky on a video.
Cool.
That's what I see.
That streak is about to change.
Okay.
That streak is about to change.
I'm being told that this is because of something.
Yes.
Okay.
Now
I don't know any of this for a fact.
Let me go ahead and just finish what I'm saying here, because we're talking about the gases and pressure and shit like that. So let me go ahead and just get that through. Now, at this altitude, we don't know what altitude it is, but let's just say it's at a altitude. There's obviously atmospheric pressure here because the rocket's gases are still relatively contained. But as the rocket gets higher and higher and higher, the gases start to expand because the atmosphere gets thinner and thinner and thinner. Eventually, the gases expand so wide that, and here's a zoomed out shot I took of it at Cape Canaveral, absolutely drop dead gorgeous. But the gases start to expand so wide that you cannot see the gases anymore, barely, when I zoom in on it.
It's amazing. It doesn't even dissipate.
Hang on. Still getting there. Now, at this particular point, you can see the gas is streaming out of the rocket as a ripple. You can actually see the ripple. Now, what's going to happen next is called MECO, main engine
ripple? Why is there a ripple?
Because it's a rocket engine. Because it's a rocket engine.
Well, yeah, I know that. A rocket engine. I don't get a ripple out of a spray can. I don't get it. Why would I get a ripple? Why all of a sudden now you're getting a ripple?
For the same exact reason you hear crackling from a rocket. It's a lot more violent than a spray can, dude. But
we're not talking about a wave.
Let me show you. So what's going to happen next is called MECO, which is main engine cutoff. And I want you to see what happens to the gases. Wait for it. Boom, right there. Main engine cutoff. You see how the gases expanded?
Those weren't gases expanding. Those were ripples of something, man. That fucking thing crashed into liquid.
Hang on. Before you claim that it crashed into something.
Hold on a second.
Okay.
Sorry about that. You got the loudest damn chihuahua in the whole world.
I understand. Anyway, so before we say that it crashed into something, because that's usually the claim at this point, they don't watch the rest of the video. The rest of the video shows this.
Yep, bouncing
Boom.
back into
Second
it.
stage ignition, which means the second stage ignited at this point to continue on the work, thus allowing it to continue on its path to orbit. During this entire sequence, we were able to observe the consequences of a drop in atmospheric pressure while not smacking into a dome in the process.
Okay, so what's keeping it from going out equalization with space then?
What's causing? Wait, repeat that.
What is keeping the gases on what we call our atmosphere from dissipating or equalizing with the surrounding lack of pressure? What is causing that? What is keeping that there?
One, vacuums don't suck, and two, it's gravity. Gravity is holding the atmosphere to
gravity is gravity. What is gravity?
Gravity is a force that pulls you down.
Whoa. You're describing an effect.
Yeah, that's
what is it? It's not, and it's not, I don't think anything's being pulled. I think it's well, no, wait a second. Not good for me. Not good for me. You're claiming gravity. You're claiming a magical force without any causation, and you're applying that gravity to other objects.
No, I did not bring up gravity in this observation. What I observed was something very simple.
Well, wait, you did. You said it's what's holding the it's what's holding the atmosphere.
No, that's a separate question. That's a separate question. What I'm talking about here is the fact that it does happen. Let's hypothetically say we don't know what's causing it. Let's say it could be gravity, it could be magical unicorn farts. It doesn't matter.
Yep, right. I agree.
The point is that this rocket was able to demonstrate a gradual drop in atmospheric pressure without smacking into a dome in the process.
Well,
this shows that whatever's going on, hang on. This shows that whatever's going on, a dome is not required.
This is what you're claiming. What you claimed was that those huge waves that I saw from that minuscule little rocket was gas. Coming from, well, yeah, at that distance, it was minuscule compared to the rings that appeared around it, these waves, and you're claiming that's gas? That gas wasn't escaping like that. Why didn't it go in all?
Gases escape out of a rocket?
Yes.
How fast?
Yes. Listen, what we've got going on here, we still have a problem. We still have the problem of a vacuum, and I know it's not a vacuum cleaner. That's just an obscure thing that people try to say to make you sound like you're stupid. I'm not talking about a vacuum cleaner. Any lower pressure system is considered a vacuum because of equalization. It will pull the higher pressure to the lower pressure in order to achieve equalization. Nature abhors a vacuum. So if you're claiming that this force is so strong, then it can defy physics, one of the fundamental laws of physics. This means that it's a force that's so strong, you wouldn't even be able to walk, because all I have to do is change the temperature of a gas, and it will either rise or it will fall. One of the two. Yes, there is a downward vector. I agree that things fall.
Cool.
But what you describe as gravity is nothing more than the cause. The cause cannot be the effect. You understand? And the effect cannot be the cause.
Again, I said we can say it's gravity. We can say it's magical unicorn farts. It does nothing against the observation that I myself made, and not just me. Other people.
I understand about your observation. We're talking about a gas pressure system next to a vacuum without containment. No,
you were talking about the existence of a dome. I just showed you.
Okay, then what is you're telling me that this thing, gravity, that you don't even know what it is what's responsible for holding? How come gravity? How come you can't recreate that then in a laboratory?
Wait a minute. How am I supposed to recreate the mass of the Earth in my living room?
Wait a second. The mass of the Earth. What has mass got to do with anything? That's an assumption. The assumption that mass attracts mass.
Even though I can base actual formulae on it, and yet it works.
Well, you can do all kinds of mathematics, but the bottom line is you cannot prove mass attracting mass ever.
Yeah, except that we can. But again, that is not my argument here. My
Well,
argument
yes, it
here
is,
that
because you're
whatever,
saying that the mass of the air is being held by the mass of the earth.
dude, you're arguing against a straw man right now. I am not bringing up gravity. I am bringing up the fact that whatever is going on, again, whether it's gravity or
Right.
magical unicorn farts, a dome is not required. You
Oh,
asserted a dome.
all right, then
I
what
showed you
then what
evidence
kind
that
of
shows that a
containment?
dome is not needed.
Okay, then what kind of containment is being used? What kind of containment is holding the gas pressure system against
I
the
already
absence of
answered
one?
that question, dude.
No, you said gravity. The magic word gravity. You don't get to use that.
Oh,
You
I
have to
know. Okay.
prove that. You have to
Okay. If I
prove
can't
that.
use the magical word gravity, then you can't use the magical word dome. How's
All
that?
right, I won't. I won't.
Perfect.
I'm
Next.
going to use the word barrier.
Cool. Let's
Containment. I'll use the word containment. You
Let's-
can't have it without containment.
let's go ahead and try this. I think we know what will clear this all up. Would we or would we not agree? If I were to hold my hand out into the wind, going, let's see how fast. Let's say about 5 miles per second
Mm-hmm.
in the air. Would it be reasonable to assume that the air would just tear my arm to shreds, considering I would be doing 5 miles a second?
Probably. Yeah, I bet you probably could.
Yeah, it would just rip my arm completely off. But if I was in a vacuum, i.e., no air, then that means there would be nothing to rip my arm completely off, right?
Right. Well,
Perfect.
no, yeah. So you're saying you're not meeting any kind of resistance.
Yeah, there would be no air resistance because
Right.
No
Right.
air. So if I were to travel that speed and I were to stick my arm out the window, but there'd be no atmospheric pressure, then nothing would rip my arm off. But if I did that exact same thing within atmospheric pressure, then my arm would just be in tatters. I wouldn't even have an arm anymore because it would just be bleh, like that, right? So,
Sure.
so the question that I have is, how can I demonstrate an absurd amount of speed while the craft in question is not being ripped apart to shreds? And that's where I bring up the International Space Station, because it is traveling at that speed, but yet it's not
17,000 miles an hour.
Yeah, correct.
Mm-hmm.
So the question I have for you is, why isn't the International Space Station not being ripped to shreds?
Because it's not real.
How do you
There
know
is
it's
no
not real?
international. It's an international fake station.
How is it not real? How do you know this?
How is it not real? Well, they film the outside extra EVAs, the extravehicular activities, in a pool in San Bernardino that is equipped with green screen. They use augmented reality and harnesses when they're doing their other little chit chats and shit. And other footage, they use zero-G planes and other special effects. It's NASA's got one of the largest film studios in the world.
And people that can
And
see
they're
the
still
space
not
station
very
reality?
good. They're
And the people
still
that can
not
see
very
it?
good. I'm sorry?
And the people that can see it outside of their own home, what are they looking at?
I don't know, but you're telling me that you can see an object just slightly larger than the largest airliner at 250 miles away when
I'm
you can
not.
barely see an airliner at cruising altitude.
No. Let me be clear here. I'm not claiming that.
No, I mean, this is what people claim.
No.
I'm not claiming. I've never seen the fucking thing.
No. I'm not claiming that I'm asserting this. What I'm claiming is that I know this, as in
Okay.
I am 100% confident that yes, the space station is 250 something miles up. I can say that we can see it with a Nikon P1000 or similar telescope.
I agree. You're seeing something, but I'm not. I'm saying there's nobody out in space floating around, man.
Not just seeing it, and the reason is because. And can you share my screen, good sir?
Sure.
Thank you. I appreciate it.
Where is it? That's mine on there right now. Hold on one second. Watch this thing. This is really cool. Somebody sent me this. This is really cool. Just to give you an idea, of people at home, speeds. This is a hypersonic sled going at Mach 8.6. And that's just a fraction of some of the speeds that we're talking about here. But watch this thing. It's like you don't even fucking see it. I don't even know what it looks like. You can't even freeze frame that fucker. They even take it back down to a half speed film, and this is amazing. I mean, it scares me just seeing it. That fucking speed just scares the shit out of me. I'm like, oh my god, I wouldn't want to be anywhere near that. Watch this thing. Boom. Anyway, here's Red's thing.
This is my video where I measured, independent of NASA, I measured the altitude of the International Space Station.
Okay.
Now, here's how I did it. I was in one spot, one location. I'll show you my my view right here. Hang on 1 second. Let me find the image right here. There we go. Here's my friend's view. He runs a YouTube channel called Astronomy Live, and he has an LX200 telescope in a parking lot. Now, I was in a different parking lot about 750 meters away. That's my buddy Bull, may he rest in peace. And here is my setup. I have a Nikon P1000, the flat earther camera of choice, and I have it attached to an external monitors to make it easier to track stuff with it. Now, again, we were observing the moon from 2 different locations. And if you look at this diagram, you will see that our lines of sight cross at the International Space Station. And as they continue, they would end up on different parts of the moon. That is called parallax.
No, I understand it. Now, wait a second. We still have to. You're assuming a distance to the moon as well.
Nope.
Yeah, you can't prove that
distance. Not taken into account. The moon's distance was not taken into account, and I will prove that in a moment.
All right, that's fine. Go with what you got. Go with what you got.
So
I'm not denying you see something go across the sky. I'm denying that you're seeing something in space go across the sky.
Perfect. Let me go ahead and disprove that real quick. So you can see our parallax measurement right here. We actually caught parallax. This was his view on the bottom. This was my view with the Nikon P1000 at the top. Because we had all this going for us, here is our diagramming, our measurements and stuff like that. You want to look at the math, you can find it on my YouTube channel, Reds Rhetoric on YouTube. And we were able to
whoa, back that up just a second. Where did you get this curvature down here from your viewing platform from? Where does that come from?
That's to complete our work. But if
why would that even be necessary? You're looking at an object going across the sky from 2 different locations, and you've proven that you both saw it from 2 different locations. This isn't proven sphericity or distance, really.
Dude, you have to pay attention to the whole thing. I say in the video that without taking the curvature into account, without it, which can be done with what is listed right here, we were still seeing an altitude of 409 kilometers. That is without taking the curvature into account. That's assuming no curve whatsoever. But with the curvature into account, we got 412 kilometers, which means that this object I was recording with the Nikon P1000, I did see it at 409 kilometers at the very least, which means the notion that you can't see this object, being that it was so far away, is flat out wrong, because we were able to prove otherwise. Not only that, but we were able to compare our findings, which is altitude found, 412.4 kilometers, altitude via Safari Pro, which is an app that you can download, 419 kilometers, which means with our method, we were 98.4% accurate. Now, you also said, but what about the moon? You're taking the moon into account.
No, I understand where you were going with that, and now that would be absolutely irrelevant.
Correct,
because you're both seeing the same size at the same thing. It's just a backdrop that you can.
Yeah, it's just a backdrop, exactly. But to complete the work, this is actually part 1 of 2 videos, and the link to the second one is by Astronomy Live using this exact observation. Now, sir, if you can please do me a favor, can you please read the title right here?
Oh, it says measuring ISS without using the moon. Yeah. Hey, listen, I'm not denying that you see an object go through the sky. I'm not denying that whatsoever. I see all kinds of objects go through the sky.
Cool.
Okay.
But did you
Absolutely.
them like we
Does that mean, now wait a second, does that mean that it's in space?
correct,
No,
because
it
there was
doesn't.
no,
It
no, it
doesn't mean
does,
that.
because
Hold on, I let you go there for a minute. Let me finish what I got to say here about that. That does not mean in any way that it's in space. It also doesn't mean that the Earth is a globe at all, any more than a high altitude aircraft going over means that the fucking Earth is a globe. None of that's irrelevant to it. It also doesn't denote the fact that you cannot have this gas pressure system where you just automatically just kind of pop out of it somewhere without containment next to a non-pressure system. A minimal pressure system differential will crush. When you go the other way, you can try to change the pressure inside of there's a video of a rail car, and they only took that down to, I think it was 3.8 psi, and it fucking poof collapsed like that. That's still within the positive range. Now we go into the other range, and this is the same effect that happens when you open your beer after work. You're right. What is that from? That is because it's equalization. Without the containment of that can, the pressure inside that can wants to equalize with the surrounding pressure outside, which is lower.
But
And as soon as that containment is breached just a little bit, equalization starts taking place.
But remember what we agreed upon. You agreed with this. Remember, if I stuck my hand out the window at speed, my arm will get ripped off. Because here's the thing. On that second video, measuring the ISS without using the moon, I was personally looking for its altitude. I wanted to show its altitude. Astronomy Live, however, went further with his analysis, and he was able to confirm. Now, let me just make sure this is clear. This isn't a guess. This isn't conjecture. This was confirmed. He confirmed that it was traveling at over 7 kilometers per second. And if we go back to what we originally agreed with, that craft should be being torn to shreds at that speed. But yet, it remains perfectly intact. And when we look at the shape of the thing, we see that it's the most unaerodynamic craft in existence.
Right. I would agree that it does appear to be that. Let me just take that a little further. In the thinner, you're right. Yes. In the thinner gases in the upper atmosphere, you can achieve higher speeds. This is why the SR-71, which is very aerodynamic and travels at a much lesser speed, can only achieve that speed at altitudes around the stratosphere. Why? Because the atmospheric density is much thinner. Okay, it still heats up because of the friction, and this is why if it's sitting on the tarmac, fuel leaks out of it because it's made so that it will expand at those high altitude, at those high speeds and altitudes. But it can't achieve those high speeds, like you were saying, at the lower altitudes without it being ripped off. In fact, a Boeing 747 or 757, although they can do close to 500 miles an hour at 35 and 40,000 feet, if they tried to run that altitude at a few hundred feet, if they tried to run that speed, the air is so dense that the movement of the control surfaces endangers the integral structure of the plane itself. So yeah, you're right about that. But we do have things that fly at high altitude. Absolutely. We also have high altitude balloons, some of which are as big as the Astrodome, that are up there right now that you don't see at all. God knows even what's hanging from those.
Can you share my screen?
We know that NASA is the largest consumer of helium in the world, and they do put out record number of balloons, a lot of them from Antarctica. What do you got for us right here? Let's see what this is. Oh yeah, the SR-71. That thing is and that's been around for a few I mean, I would guarantee that they've got shit that's way better than that by now.
Possibly, but let me just ask you this.
What was it? Wait, real quick. What was that? Like 1968? Something like that?
Something like that. But the question that I have for you is this: what looks more aerodynamic? Would it be this SR-71 Blackbird, or would it be this actual image captured by Astronomy Live?
Yeah, I'm not doubting that. I've seen that picture before. I don't know what it is, but I do know
this picture. Hang on, let me just explain something. This picture is of the same International Space Station captured with the same exact equipment, or mostly the same equipment, different scope, the same camera that was attached to it. This was captured by the same person that helped me make that measurement that I showed previously. This shows that this unaerodynamic craft, which we confirmed is traveling at 7 kilometers per second, looks like, well, the most unaerodynamic craft in existence, as opposed to the XR-71, which cannot go anywhere close as fast nor as high, which means in order for this craft to survive with it being the shape that it is, traveling the speed that it's going, it would have to be in an environment where atmospheric drag is not a concern. Where would that be? Kind of sounds like space to me.
It does kind of sound like that. It does kind of sound like that,
doesn't it?
If indeed the object that we see, if indeed the object that we are seeing is actually what we're told.
Well, keep in mind,
I agree with that. We also hold up. We also know that there are streams of wind at high altitudes that go phenomenally fast.
They travel at 8 kilometers a second.
I don't know. Maybe some of them are pretty fucking fast. Where's that? Oh, they took that down. They took that down. There used to be a thing that you could actually track the winds.
Yeah, but here's the thing. Here's the thing. The winds are not what's being tracked with this. The way that we were able to find the transit of the International Space Station is that we were able to predict where it was going to be 2 weeks prior, which means that goes well beyond what meteorologists are able to predict.
Let's assume. I'm going to go ahead and assume that this thing is out there flying around in space. You still haven't addressed how the fuck we could possibly have an atmosphere against space without containment, unless space is not what we're told.
Again, I already gave you the answer, but
no, you said gravity, which I just showed. I can show you that gravity is bullshit. You ever seen a hot air balloon? You ever seen a hot air balloon? A submarine?
Again, whether you accept it or not is beside the point. What I'm saying is
no, it's not. That's the whole thing. That's the extraordinary claims that must be proven. Before we go to finding out how the flowers are growing in Narnia, we have to determine that Narnia even fucking exists.
Much like the dome.
Well, there again. So if there's no dome, and I'm not saying concretely that there is, I'm saying there has to be containment. And you can't just yell gravity when nobody even knows what the fuck it is. The worst part of it is within astrophysics. The worst part of it is that they are saying that the cause is the effect. The effect is the cause. It's not. And so they ascribe this principle to other objects that they observe, thinking that and it's an assumption. It's all an assumption. So what we have to prove is not only sphericity of the globe, which would be as simple as measuring curvature. We don't have to do all this. We can just measure curvature. Okay? That's first and foremost. And we also have to demonstrate. We have to demonstrate this thing of gravity. We have to say, okay, how would it be possible for this to exist where it's holding water onto a ball that's rotating at, what is it, 1 degree an hour? Or
no, it's
15 degrees an hour.
There you go.
15 degrees an hour. So it's doing all that while simultaneously going at a phenomenal speed around the sun while traveling in a perpendicular direction, chasing the sun.
Well,
as it flies away from the Milky Way and the other phenomenal speeds, but we don't feel it because of math. We have to demonstrate that that's absolutely possible at all. And we can't without assumptions and speculations, one of which the magic word gravity.
again,
Yes, we all determine we can measure the rate at which things fall. Yes, we can. Do they go in a downward direction? Yes, they do.
And what makes that downward direction not applicable to the atmosphere?
Well, just a second. It does. It absolutely
it
does.
So a dome is not needed.
Wait, yes. Hold on. Wait. Hold on. Don't cut it off. You only got half the equation, because now we have to put that next to the lack of any pressure system whatsoever without containment and prevent equalization.
You mean
I'm saying that there is not a force. The force isn't strong enough to do that, because let's think about that. Let's think about that pressure differential, and then just think about the fact that I can trap this air that's being held by gravity inside of a contained vessel, heat it up a slight few degrees even, and it starts to lift away from this gravity that's supposedly holding it against an immense pressure differential.
I have no idea why you're so hinged on this gravity thing again.
Well, I'll tell you why, because without it, the rest of all this shit falls out of the way.
Geometry.
You see, because 90% of the speculations that are used in all of this are hinging on gravity. For instance, the impossible idea of everything sticking to a ball and being drawn to its center without any evidence whatsoever, it's actually quite ludicrous if you think of it on face value. If they waited until you were about 15 years old and tried to run that shit on you for the first time, you'd think they were crazy. But since you've been indoctrinated into it since you were 5 years old or before,
it's called indoctrination.
It is indoctrination, because it requires belief,
not
an acceptance of impossibilities. The acceptance that water, which remains level when undisturbed, can somehow wrap itself around a moving object and adhere to its shape, is a ridiculous concept. That is a ridiculous claim that must be proven.
I see. Okay.
And the only way that can be proven, and through the gold standard, is to demonstrate this through a repeatable and demonstratable experimentation. This is also has to be proven, because the extraordinary claim is a gas pressure system within the lack of a pressure system, or a lesser pressure system without containment. This is not possible. So an experiment, a repeatable, demonstrable experiment must exist that can show this to be possibility.
There are over 50
you can write down numbers. You can write down numbers and make equations based off of your assumptions, and that's all it is. It's equations worked backwards from an assumption. I
didn't show numbers, dude.
I know you didn't. I'm just saying within general.
Yourself. I didn't have to go to NASA or SpaceX or ESA or any of the kindergarten teachers that I had when I was growing up. I didn't have to do any of that shit. The only thing I had.
Where did you first get the idea that the world was a globe? Where did that idea? Did you come upon that on your own, or was that told to you?
Do you think that the origin of an idea, as opposed to its validation, are
just
two
answer the question?
things?
Were you told that, or did you come to it on your own?
I was told that, and I verified it myself.
You verified it yourself.
Correct.
So and you had to jump through a lot of hoops to verify it, to prove to yourself that what you
actually
sense.
doing the work?
No,
yeah.
What I'm saying is trying to prove to yourself that your senses, everything that you think, everything that you feel, that you observe, and everything that you know deep inside is completely fucking wrong because of math.
Completely fucking wrong because no, I'm not saying anything is wrong. I'm saying that I understand geometric consequences. They are geometric consequences to living on a spherical Earth.
Wait a second. Let's prove that it's a sphere. How are we going to do that?
I already told you about the Equatorial telescope mount and the
No, that doesn't prove anything. That proves that you see different star rotations. It proves that you have to. No, it doesn't. It proves that you see objects in the sky, you track them with a telescope, and this is where it tells you to move the telescope to. That doesn't prove sphericity. That proves that there are lights in the sky moving, and you're tracking them with a fucking telescope. That's all it proves. It doesn't
Yeah,
prove sphericity.
No.
And if there's any
that's-
sphericity, it's within the lensing system of what you're looking at these objects through, not necessarily your telescope.
So you're saying lensing would make my one axis rotation dependent observation needing two axes?
I'm saying that the sphericity of the Earth would not be the only explanation for such a phenomenon.
Then come up with a equally substantiable
Okay,
explanation.
all right. Those objects, I got one. Those objects move in the sky and from a certain position on Earth.
No.
Seems to be the
Here's the thing. I'll go ahead and make this very, very easy. You provide me. I made a 3D model, and I know a guy that can make models for you.
I want proof.
That
I don't want fucking speculation. I don't want cartoons. I want proof
whether you
of a
accept
sphere Earth.
It is proof. So
no, it's not proof. It's a cartoon.
Oh,
I
so
want absolute 100%.
Accurate and precise predictions is irrelevant to you?
All right, no. What I'm talking about is let's. All right, so when you measure for curvature, and there again with your same Nikon that you were looking at the space station with, right? Mm-hmm. And we see objects way further than we should be able to see on a sphere the size of the Earth, merely by bringing them back into view with a telephoto lens. Tells us that we're not on a ball the size of that they tell us, or that we're not on a ball at all, because you end up seeing more horizon. People confusing the physical horizon, of course, with the visual horizon. You're not seeing a physical horizon. You have a limit to your view. This is why when you pull in something off of with a telephoto lens, hey, there's the full object, and oh, look beyond. There's more horizon.
Can you share my screen?
Yeah.
Thank you. I have a bit of a problem. This is a picture I took of Tampa, but I actually took two of them. One of them was from the north side of the Skyway Bridge with the Nikon P1000, apparently the only camera that doesn't make real-time CGI. Whenever I try to overlay the two images together, I always confirm curvature for some reason. Can you help me out here?
Sure, absolutely. What are you doing here? What are these two images?
I'm doing what's called a blink test. Can you please explain why, when I take the picture of the exact same field of view from the north side of the Skyway Bridge, I'm confirming that people are drowning underneath a hump of water?
No, you're not at all. That's a deceptive picture.
Oh,
you don't overlay them. Don't overlay them. Show one, then show the other, because
I'm being deceptive, guys.
Totally you are. Deceptive. You absolutely are. You're trying to put the same buildings from that picture onto a water horizon.
A what? No,
no. Look, this picture. The picture with the water in the middle of the horizon, right there, is obviously taken from either a different distance or even in a different direction. And you're overlaying it with a picture taken from a closer distance. It's deceptive as shit.
No. This image.
Oh my God!
This image was taken from three. Oh yeah, hide my.
Yeah, I'm going to, because you know exactly what that is. That's fucking horse shit. That's the kind of stuff that I'm talking about.
Of what I was able to bring.
No, I'm not scared of it. It's not showing anything other than you overlaying two pictures. You want to see some shit? Hang on a minute. I'll show you some shit. You want to see some shit over a horizon?
I got my own live stream. So as you can see, guys, this is what he is scared to show.
We're not scared of anything, dude.
Then show it.
See, this is always your go-to. This is always your go-to right here, because I won't look at some deceptive shit. You already showed it. You want me to put it back up? I'll put it back up. There it is. There it is. There it is. What are you showing? What are you showing? I'm going to bring you something. Hang on a minute.
This image was taken from 3 miles away. This image was taken from 24 miles away. The question I have is a very simple one. Why is it that in the further image, even though I'm dealing with the same field of view, I cannot see the bottom of those buildings? Why?
I don't know. I don't know enough about how you took the picture, to tell you the truth.
Distance. I already told you.
It's not just distance. You know that. You know that.
Camera.
How did the buildings? If you took the picture from a different distance, then how come the buildings remained exactly the same fucking size? Do you think I'm stupid? Jesus
called
Christ,
Zoom,
bro.
dude. You're supposed to be an expert on the zooming shit because
Look,
you
look,
brought it up.
look, look. I'm going to show you something here.
It's called Zoom.
Yes,
Oh
I
my
know what it's
God.
called. We're going to show you some Zoom. Okay?
Why
Let me
is it that I
see.
can't see the bottom of these buildings from 24 miles
All
away?
right.
Please answer that question.
Hang on just a second. Let me see. Is this...
Can you answer that
There
question?
we go. Hang on. I wasn't listening. I'm looking for something. I
Of
just
course
told
not.
you that. Well, just fucking chill out for a second. I told you I was looking for something. Repeat the fucking question, if you will.
Why can't I
Don't
see?
shit on the fucking chessboard, kick all the pieces over, and then strut around like a goddamn chicken thinking you won something. You haven't proven shit.
No, I'm
What
not.
do you live? Hold on a second. Here's another thing in your field of view. I don't see any curvature from the right to the left. I see
Oh
a
boy, don't worry.
horizontal horizon. What do you live on a fucking cylinder?
Oh, don't
Are
worry.
you
We'll get to that
shitting me?
in a moment. We'll get to that in a moment. But the question remains: why can't I see the bottom of the buildings?
Well, we're gonna cover that right now. We're gonna cover that right now.
Why?
I'm gonna show you. Hang on a minute. Wait, I want this. There we go. Is that the yeah.
Am I supposed to be looking at something here?
Yeah, you are. Look at the fucking screen. Don't start turning into a dick, because that's what you guys do, man. And then you claim, and then you kick over all the pieces on the board and shit on it and claim, oh, I won. See, another flurf. Ho, 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 ho. It's like you use no logic. I'm going to show you something. Do you see the ship? You see the boat? Do you see the boat? All right. What's happening here? What's happening when we bring in? Now we do have the effects of waves and atmospheric porosity, atmospheric density that occurs there. But as you can see, watch. Oh, look. Why is it going out beyond my sight? I can't see it. It went over the fucking curve. Oh my God. Well, I must live on a cylinder. There it is. Oh, look, it must be going over a curve because it goes from the bottom up, because that's how perspective works. Everything goes in toward the vanishing point. This is why the horizon remains at eye level. It doesn't matter how high up you go up 35,000 feet. The fucking horizon is right there.
That's incorrect.
No, it's not.
No, it is. The horizon does drop.
The horizon stays at eye level. If it didn't, you would see it drop below you, and you don't. You can look out for miles and miles and miles right out the side of the fucking airplane.
Go ahead and share my screen, please. This is my video, as you can tell by my intro. You see the logo that I have on my screen, right?
Wow. Yeah, neat.
Okay, cool. So this is my intro, and I'm not taking anyone else's. You did actually request that I bring my own stuff, right?
No, I said I didn't request anything of the sort. I requested that we didn't resort to, as you did, to ad hominems, which you went right to in your announcement of your debate.
Cool.
I might add, you did.
Because apparently not understanding the shortness of a word is considered slander. Got it.
No, it is. It's used as a derogatory term to deride anyone that doesn't buy the bill. Now, there again, look at. Oh my God, it is a globe. See that curve? Oh, wait, it went away.
Bro, that's not the video.
I know. That's my point.
Yeah,
they use that a lot.
One in a moment. So what I did with this drone was very simple. What I did was I marked the horizon with an arrow. That's the arrow. Now, the arrow does not move in frame. Can you confirm for me, sir, that the arrow is at the horizon?
It looks that way, yeah.
Perfect. I'm glad we're in agreement. So what I'm going to do is I'm going to press the stick up, and I'm going to be like, fly, bitch, fly. I want you to fly up as high as you will possibly go. And thus it happens. I'm going to skip ahead if you don't mind, because...
No, let it play.
Oh, let it play the whole thing?
Yeah.
All right, let's go ahead and do this. We're taking the
we're talking about what is it, 7.9 inches per mile squared? Let's see that fucking shit. Let's go.
So much, my God. Anyway, so...
What? Hold up, what? What did you just say?
Equation.
No, it is. What is the right equation?
The square root of r plus x to the second equals r to the second. That's the right equation. But I'll go ahead.
Okay, so how much curvature is there in 1 mile?
In 1 mile?
Yep.
No, about 8. Anyway.
About 8 what? About 8 what?
I don't know, inches?
Oh, okay. How many at 2 miles?
We'll get to that in a moment. First,
no, for real. You just told me that you're already on the same thing. If I've already got 1 mile at 8 inches, but go ahead and let it play.
You agree now
that we can let it play. Let it play. I don't agree to anything. I don't know. You haven't moved the arrow.
Oh, okay. Let's try this again.
Listen, you've already shown that you're willing to use deceptive things.
Oh, you're calling me deceptive? Fuck you.
Yes.
Put your finger on the arrow. Put your finger on the arrow on your screen.
Dude, it's on a screen. I'm talking about what I've witnessed in my own. I've witnessed this in practice. I've been in airplanes. I have been in airplanes. I've been on mountaintops.
Doesn't move.
Listen, I don't care what your video is showing. I don't know that you didn't move that. I don't know that the drone didn't tilt back a bit. There's all kinds of variables involved here. If I were to tilt,
the camera is on a gimbal.
It's on a gimbal. Okay, all right, go ahead.
So
keep going.
You agree that the arrow does not move? Let's just assume that for a second.
Well, okay. We'll assume that. I can go with that. I can't agree to it because I don't really have any veracity into the legitimacy of this.
I'll tell you what. I'll go ahead and I can repeat this observation for you with you in person. Let me know.
Hey, how about this? I can go ahead and be on an airplane. I've been on fucking airplanes. I've been on airliners, private planes. I've been on top of mountaintops, and the horizon has always remained at eye level.
Cool.
Every time,
play this video.
Every time, as far as I can see, the horizon will always be at eye level. This is my own experience. Blow your fucking
mind with this video.
It's always been in my. Well, there again, I don't know the veracity of this video whatsoever. Well, you claim that you have a video that you made. That's all well and good. You know what? NASA also claims that they have people on a space station, but then I see them glitch out. And then, wait a second. I am saying to you that there's all kinds of things that can be gone. Now, I'm not seeing a whole lot of deviation there. Really not.
Oh yeah, it's almost like the planet Earth is fucking massive. Thanks for the observation, Captain.
Well, yeah, I understand. What did you just say? Did you
I said thanks for the observation, Captain Obvious.
What was that? Why was that necessary?
Because apparently you are making the claim that, we should see this shit falling off like fucking Niagara Falls or some shit.
No, I did never make that claim at all. That's your claim. That's your claim of what I think.
That's what you just did.
I did not say that whatsoever. I did not say that whatsoever.
Yeah, of course.
Where did you get the idea that I said that there's water falling off somewhere? Where the fuck did you get that idea?
I didn't say you said that there was water falling off. I was talking about curvature and
where is it?
Over something.
Where is the curvature? It should be left to right too, right?
Left to right. Okay, let's go ahead and take that on board. So what I did here is you can see
you should be at the highest point of the ball anywhere that you're at in the ocean.
Cool. Let's take that on board. I will take that on board. I will take that. So let's go ahead. This arrow, which was where the horizon was, is now above it, showing that the horizon did drop. That's the first point. Now you said this horizon is straight across.
You're not seeing the whole horizon. The arrow is at the horizon. No. Zoom in.
Why am
Zoom in and you will see that the horizon is at the fucking arrow. You have to zoom in. You're not seeing the rest of the horizon due to atmospheric opacity, but it goes beyond that blue line. That horizon is beyond there, right where that arrow's at. So there's where the deception lies. You need to zoom in right there. If you were to zoom in with your lens, you would see that horizon is actually beyond what you're seeing at that point right there. You're recording a visual horizon. At a higher altitude, you will. At a higher altitude, without the atmospheric opacity, you would see more horizon. Okay.
These clouds are below the arrow. So the
No.
clouds are the horizon?
They appear to be below the arrow, but that's because they're further away. That's all.
The
That's
further
all.
okay.
Okay. And just like I said, with the perspective, is that the horizon is actually where that tip of the arrow is at. Hold on, don't interrupt. It's where the tip of that arrow is at. The reason you don't see it is because of atmospheric opacity and because you don't have it zoomed in. You can only you're still dealing with a visual, you're still dealing with a visual limitation. Once a zoom would be employed right there, you would see that not only does that horizon stay there, but as you go up, there will be more.
There will be more. Okay. So what is perspective to you?
Perspective is that you have an angular limitation to your vision. Everything that you look at vanishes into a central horizontal point. Everything comes down. This is why when you look down railroad tracks, they appear to becoming narrower and narrower as the distance increases until they end up just being one line.
Do we see
but that's only due to your perspective. It's not really doing that.
Distance?
Now going up to down, okay, you can equate that to when, like, if you see a row of street lights and you're standing on a street and the street's level, all the street lights are actually at the same height, but it will appear to you that each one consecutively is shorter than the next, all the way down until, if it's long enough and you can see far enough, it's going to meld into the horizon. It's going to look like they just shrunk right into the ground. But if you increase the magnification, you'll bring those things right back into view and see them in the perspective once again with the same perspective, just a closer view.
You do
It'll
realize,
just be like you moving up closer to it is all.
I love how the streetlight example is so fitting, because have you noticed that the streetlights appear to be smaller as they get further away, and yet that doesn't happen with the sun? Just thought I'd point that out.
Yeah, but, well, yeah, it does. But you know what else? When it's very foggy, not really foggy, but very humid here in the Shenandoah Valley, that moisture in the air, I've noticed, will actually magnify some of those streetlights. They actually get smaller when I get closer to them.
I'm in Florida, dude. We invented humidity.
Oh, I know. Yeah, the Shenandoah Valley is pretty bad in the summer.
I can tell you that the sun remains the same
doesn't last
throughout the day.
Yeah. Okay.
It does. It really does.
It does what?
The sun remains the same angular size throughout the day. On a flat Earth, the angular size will have to change by a factor of 2.
No. Well, wait a second. What kind of a size are we talking about?
If we assume
what is the size? What is the size and the distance of the sun?
If we assume that the sun is 65 kilometers across and about 5,000 kilometers in altitude between morning and solar noon on a flat Earth, the size would have to increase visually by a factor of 2, only to shrink right back down again at sunset.
So that's basically okay, I agree, but you preface that with, if we assume. Okay.
Correct.
So who is assuming that?
Flat earthers in general. They say the sun
flat earthers in general. I'm a flat earther. I don't assume that.
How far away is the sun?
Hold on a second. Wait a second. No, you tell me how far away and how high it is. It's your claim. How far away is the sun, and how big is it? And how would you possibly know any of that?
I'm not making the claim at all. I said that flat earthers have been making the claim that the sun is small and local. By small and local, they give rough figures between 5,000 kilometers, 6,000 kilometers. They say it's about 32 miles wide or about 65 kilometers wide, somewhere around there. If they were to go with those, let's just say we can take any of those assumptions that flat earthers routinely give us. Like, for example, Eric Dubay. Eric Dubay on Twitter has said repeatedly that the sun is small and local. And he also quotes a book, which the name of it escapes me right now. But if you read the contents of that book, the book—
Is it Zetetic Cosmology?
That might be what it is. Again, the name escapes me right now. But with that book and the contents within it, if you read it, it says that the sun is about 3,000 miles up. That's roughly about 5,000 kilometers in altitude. if we take those assumptions on board, let's just accept that face value. What are the consequences of having a sun that close and at that size? The consequences are that if the sun was going over the equator as it does during the equinox, the sun would rise at one angular size, grow to twice as big midday, and then shrink again by sunset. But when we actually do the observation, that doesn't happen. The sun remains
when there are observations done with polarizing filters, there is a change until it actually just fades out of sight itself.
It doesn't
because of distance and atmospheric opacity. See, you got to also understand that sunlight and daylight are not the same thing. Those are two different things, although they're connected.
Wait, what?
Yeah, sunlight and daylight are two different things completely.
Okay.
Yeah.
Gonna have to do a hard disagree there, but what were you saying?
Well, you're welcome to do that. You're welcome to do that. But the thing is, the claim of the heliocentric model is that we have a sun that is 836,000 miles in diameter at a distance of 93 million miles. Now, how does anybody fucking know that?
We can measure it.
How?
Oh,
and don't tell me parallax, because there ain't enough. That's a fucking bullshit word. They were determining this. They determined this fucking distance long ago, and it has changed. And you're one of the top guys, your scientist Newton, said whether it be one distance or the other, it doesn't matter. It suits our purpose. It was a very scientific thing to say.
You told me to bring up stuff that I personally did, or at least that was my assumption.
Well, no, I did not tell you that at all.
Which is why I said at least that was my assumption. And so I was very careful to not bring up Newton, Einstein.
Well, that's fine. I'm just saying, how would anybody know this?
Because
you would have to know the size in order to calculate the distance.
No,
you would have to know the distance in order to calculate the size.
No,
or you would have to have something of a known size and distance that you can compare it to.
Here's the thing. You are saying that parallax is bullshit. You said that. Well, unfortunately, parallax is how we were able to confirm the distance to the International Space Station and measure its altitude and speed. But also on top of that, we were able to do two different methods. Astronomy Live did not use the moon. I used the moon. We then compared our results to what was the quote unquote accepted value, and all three of us.
Well, wait a second. Did you have any known values in your calculation?
Known values, yeah.
You had known values. Okay. Yeah. So now we're going to apply that known values aspect, which are required. Those known values are required because you cannot tell the size nor the distance of an object without knowing one of the numbers. You have to either know the size or you have to know the distance. Or you have to have something of known size and distance to compare it to.
You mean like the positions of the stars?
Well, how do you know how far away a star is?
We don't need to know how far away a star is. We only need to
know the position of the stars. You just said by the position of the stars.
Yeah, position and distance are different things.
Well, what we're trying to get to is how would you measure the distance and size of an object without any frame of reference to get those measurements from?
We know positions of stars as they appear in the sky. This is how astrometry works.
I understand that.
Okay, if you
still have to know, that's still not going to tell you a size or distance. That's still not going to tell you a size or distance.
Understand that? Then you understand that those astrometry points can be used as a reference.
Well, no, those are assumed. Hold on. Only if you use assumed distances and sizes.
We didn't have to assume shit with the position of the stars. What assumption is
there?
What
do the positions of the stars have to do with the size and distance of the sun? Nothing.
Again,
Nothing. You're looking at an object, and hold on.
answer.
You don't know. Wait a second. You don't know how big or how far away the stars are.
We don't need to know that.
Well, you need to know something to have a frame of reference by, because you can't just go, there's an object with no frame of reference.
We do.
What?
That's how astrometry works.
Well, I'm not, okay, that's how astronomy works.
Okay.
Great. So they use the position of the stars. How do they do that?
Okay, so with astrometry working, being validated, thank you, finally, we got
validated by who?
By the fact that astrometry works. Ask old-timey sailors, they'll explain it to you. So, moving on, when we look at, for example, I want to preface this by saying you're about to get a sneak peek at something, because not even my audience knows this.
Oh, so boy. Okay.
I'm about to give you like the lowdown in my audience. I'm sorry. I was trying to keep it a surprise, but
I blew it. Y'all throw eggs at me.
Yeah, no, it's not eggs, but I guess we can consider it an egg.
Whatever.
Astronomy Live and I didn't only measure the distance to the International Space Station.
Red, let me stop you right here before we go segueing off into that. Wait a second. You calculated those things with using known values.
Like the
known values. Okay.
Yeah.
Now, when you're calculating the size and distance of an object in the sky, you have to have known values in order to calculate that. Okay. Now, as far as any of the things in the sky else that you see, you're in the same boat with it, because you have no known values to go by. So
you're already changing the subject. So I'm going to
say this was the subject. This was the subject.
That's your
in order to prove, we have to go to that. We have to, how in the world, because everything else is based off of these numbers as calculations for all of the astrophysics. It's all based off of this. And if that is based off of the idea that the Earth is 93 million miles away from an object that's 836,000 miles in diameter, we have to prove that distance. Now, how do we prove?
Let me talk.
Well, how can you prove a distance or size without knowing any known values?
That is your assertion. I simply don't accept it. So again, to give a spoiler, again, this is a big spoiler, so I apologize to my audience here, but a big spoiler here. Astronomy Live and I did not only measure the distance to the International Space Station. On December 6th, I want to say, maybe it was December 5th, but December of this year, early December, I traveled to Colorado, and Astronomy Live stayed in Florida. We measured parallax of Mars. With the parallax of Mars being known, we also measured the.
Wait a second. How far away is Mars?
It was 0.54 AU, I believe.
And what frame of reference did you use to be able to calculate that? You had to have a known value. You had to have a known value, right?
Astrometry. We used
astrometry. That's a word. What known value did you have? Did you know the distance or know the size?
We knew it. We knew the angular separation based on astrometry. I just answered that question like 3
In other words, here we're back to fundamentals, though.
Now,
we're back to fundamentals. Hold on a second. We're back to fundamentals. You cannot. So then, what you're saying is that it's assumed.
So as I was saying, not
assumed distances and sizes.
Not only did we do that, but with the fact that we were able to get both the distance to Mars figured out and the angular size of Mars figured out.
Based off of what? What was that based off of? What?
But I need to finish.
That's what I want to know. I want to know what known value did you have to be able to calculate Mars's size and distance?
Can we please let me finish?
I was just trying to figure out how you knew how far away the fucking sun was. You're wanting to turn it into all this complicated shit. But there again, we run into the same problem. You have to have a known value.
Okay, to you when you only listen to half the fucking answer. So
I just ask a simple question. What known value did
if you
have?
shut up, maybe you wouldn't have to ask the question. Let's try it and see what happens.
Well,
So,
okay, we'll
as
try
was
it, but I
saying,
guarantee
before I
you
was
won't
rudely
answer the
interrupted for
question.
the third time.
You won't
that
answer the
with
question without an
with
assumption.
that
I guarantee it.
information known, we are able to confirm with the help of a geostationary satellite and the International Space Station to verify Kepler's third law, we can figure out the distance to the sun. Now, you wanted it explained simply.
Mhm.
I want to show you this. Can you please share my screen?
Sure.
Thank you. You want me to explain all of this shit simply. This is all math. This is a baseline of what we
All right.
do.
We don't have to have it that complicated. I'm
We
going to put
don't
it right
have
out there for you right here, right now, this is the bottom line. If you are going to calculate the distance and or size of a distant object, you have to have a known value.
Like astrometry.
Well, okay, astrometry. Let's say that. We can use that word, astrometry. So I'm going to simulate. I'm going to simulate this for you. Okay. So
what? Repeat that word.
For simulate.
Okay.
Okay. It's a cool word, isn't it? Doesn't mean shit, just like the other one. Okay.
Astrometry?
What I'm trying to, yeah, that's exactly what I'm saying.
Astrometry is a thing, dude. I'm pretty
Okay,
sure.
what exactly is that then? Let's break it down.
Astrometry is the position of stars relative to other stars. With that being known, you can make parallax measurement using them as a reference.
Okay, great. That's what I'm trying to get at. Now, how the fuck do they know the distance of the fucking stars?
Hey, you don't need to know the distance of the fucking stars to know their position in the fucking sky.
Sure you would, because that would tell you the speed at which they're going to those positions, wouldn't it?
They don't move night to night, you dumbass.
Yeah, they do. Fuck. They move. They absolutely do. It is.
Yeah,
look,
they move.
Well, okay, great. Okay, all right. Let's go with that. You see, for instance, a star right there, the one that's that kind of looks like it connects up with Polaris. It's right there at the handle of the fucking Big Dipper. Okay.
Do you like
Hold on a second. You're looking at that star. There it is. And now tell me how you know, based on its position, how far away it is and how big it is. Tell me how you know that.
About the distance to the star.
Okay, well, you would have to, because you're using it as a frame of. Okay, so what would that matter? That would absolutely matter. How would that tell you if you don't know the distance to them? How can you compare that to the distance of the sun in order to be able to calculate that?
Okay, we're gonna have to break out the crayons for this one. Can you share my screen?
I mean, for real, it's a simple question.
And I'm going to give
you.
It's
a real simple question. It doesn't require wizardry. Can we agree that in order to calculate the size, calculate the size and distance of an object, you have to have a known value? Movement of another object that you have no idea of its size or its distance is not any frame of reference to go by. All that does is tell you how far another object you don't know anything about moved in conjunction to this object that you don't really know anything about. That's all it tells you.
Can you show my screen? All right, cool. I'm going to make two dots. I'm going to make this dot right here, and I'm going to make this dot right here. Let's assume these dots are stars in the sky.
Mm-hmm.
Now, I'm just going to pull random numbers out of my ass here. So let's hypothetically, not actually, but hypothetically say this star is 500 light years away.
How do you know that? How would you know that?
It's an assumption.
Right, absolutely. That's what I'm saying.
An assumption for this example. Thank you again, Captain Obvious.
Well, there again, do they know the distance of these stars that they're using their starometry or whatever the fuck with?
This is an example. Follow along. Let's say
go for it.
This star is 1,000. Let's just say that. Let's say this star is 1,000 light years away.
Okay.
So we know, or let's say we don't know. Let's say we don't know this distance and we don't know this distance. But I take a telescope. I slew to this star. I have it in the center of the frame.
Okay.
And then I take that same telescope and I slew it this way towards this star.
Uh-huh.
In the process of it slewing
Uh-huh.
between these two stars, it was able to measure 1.0 arc seconds of deviation.
Uh-huh.
It was able to measure that separation directly
Okay.
using the telescope's motor.
So we know the position of the two different objects, right?
Now, hang on.
Okay.
Let me just
All right.
finish.
I'm just getting at it. Now, in this example that you're using, we have values, right? Regardless of whether they're made up values or not. We have values here, right? We have
Now-
1,500. And
Okay.
we know that
Yes,
perhaps
exactly.
one object appears to be bigger than the other object, but we
That-
don't have any way of determining that they're just different size objects the same distance away. We don't have any way of
I'm getting to
determining that this is a smaller object closer and that's a large object further away. There's no way of telling that.
I'm getting to that. Now, what I'm going to do is this. I'm going to move this over here. I am going to Control C, paste, put it right down there. I am going to remove that. I'm going to remove that. Let's fix this line I fucked up by doing that. Now, in this star, I'm going to make this one 1,000 light years. And I'm going to make this one 2,000 light years. Again, where this is the only thing. Now, in the process of slewing between this star and this star, the telescope had to slew, again, 1 arc minute, the same as this. But yet we have two different distances between these two different stars. So it's almost like the distance to the stars are ultimately irrelevant because they have the same deviation in terms of the angle that the camera has to slew. Therefore, the distance to the stars are irrelevant when it comes to their position in the sky. Does this make sense?
Not really. I mean, it makes sense what you're saying, but I don't see how any of that could tell you what the size and distance of another object is just because their positions change in the sky.
Can you?
I mean, that's no indication of anything. How do I tell if that would be like me trying to see what kind of gas mileage my vehicle gets by studying the lawnmower that the guy uses on my lawn? I mean, it's just like, what the fuck? No. It's like, what does that have to do with anything there? So you see these lights in the sky change positions, the fixed stars, as we call them, they change positions. Okay, big deal.
You don't understand this example? You seriously don't understand this?
I'm saying, do you or do you not have to have a known value in order to calculate size and distance of an object?
I'm giving you the known value, and I've explained.
What known value? The position of two objects. It's just two objects in the sky.
The stars are known.
Hold on. Wait a second. It's two objects in the sky. You don't know how far away or how big they are.
We don't need to know how far away they are. We only need to know their position in the sky. That's what I'm trying to tell you, and that's what this example is trying to illustrate. But you're not.
Well, that's not. I don't see how in the fuck that could possibly. That would be like me determining the size of my next door neighbor's swimming pool by watching a car go by outside.
If you knew the angular size,
what in the fuck would that?
Pretty sure determination.
No, you have to know either the size or the distance of these fucking stars and how fast they're going, or if they're moving, or any of that shit before you can even determine what the fuck the closest one is.
This question: does astrometry work?
I don't know. It seems like there's a lot of assumptions in it.
And when
can they track positions of stars? Yes, I believe that you can track positions of stars. Absolutely. Do I think that you could use that without knowing a distance, or a size of these stars, or a speed? You have all. So that just tells you where the fucking sun is. It doesn't tell you the size or the distance of it at all.
Again, The reason why you're saying that's because you haven't listened to the whole answer, and you.
I have listened to it. You're telling me that the positions of different stars can somehow tell you the size and distance of the closest star, the sun.
We don't need to know the size and distance. We don't need, again, if you bring up the size and distance, you're doing it wrong. You're already way off into left field.
Then all it is just movement. So you're saying that the movement of points of light in the sky can determine the size and distance of the sun.
They don't move night to night.
All right, wait a second. You are telling me that by tracking what appears to be the movement of stars in the night sky, in other words, where this one's at and where this one's at, you got two different stars. You don't know how far away they are. You don't know how big they are. You just know that there are 2 points of light in the night sky. And you're going to use those 2 points of light, how far away they appear to be from you or to you, through switching your telescope view, that somehow that change in location in your telescope is going to tell you the size and distance of another object. When you don't know anything except where the position of these two objects are. That makes absolutely zero sense.
Let me make this very, very easy. I will go ahead and just give up on this point if you bring up distance to stars or size of stars.
Well,
again,
how would their position? How would their position determine the size and distance of another object you're looking at?
Because that object is in that field of view. So, for example, if I'm in one location and I see Mars in front of a certain pattern of stars, and I have another observer in Florida that's observing Mars over a different pattern of stars, if I know the separation between that pattern and this pattern, I can figure out the parallax. With that parallax value known using astrometry, i.e. using the background stars, we're able to get an actual angle. Because astrometry allows us to utilize the background stars. We know their position. Therefore, that is the ruler that we're using. And you can even measure the separations of the stars directly using
whoa, hold on a second. You can measure a separation of the stars? Yeah, you can. Absolutely.
Yeah, exactly.
And you know what? Two objects very far away from each other at a long distance will appear the same as two objects that aren't very far away at a closer distance.
Correct.
So, and you'll get the same fucking angle. So now what's in question is the distance to those objects. You don't know those distances.
The distance to stars is irrelevant.
No, it isn't, because as I pointed out, small objects close up appear the same as large objects far away.
Neat. Anyway,
they do. This is one of the earliest cinematographic tricks that they used for special effects.
Yeah, there's actually what you're describing has an actual equation to it. So
yeah, I know there's all kinds of fucking equations.
Yeah, but
what I'm telling you is this: I don't care about your equations.
Yeah,
you have to have known values.
That what you're stating is irrelevant, but you don't see it.
No, it's not. We're talking. Are we or are we not talking about how you would know the distance to the sun?
Yeah, but you keep bringing up the distance to stars, and if it has anything to fucking do
with how would their movement, how would their positions in the sky determine a value that would give you distance and size of the sun?
The separation of the stars are known. That's how astronomy works.
Wait a second, they're known. Yes, they are separated, but what part of the separation is known? What actual value is known?
Them. So, for example, if I'm looking at some stars in the sky, and let's say in order to get to a different star in the sky, I have to slew a certain number of degrees. I can say, okay, that star and that star are this many degrees, whatever that may be, apart. Right. Now, let's say I do that exact same measurement for two different stars, and then two different stars. And two more stars, and two more stars, and two more stars, and I keep going on and on and on until
Congratulations, you found their positions.
Yeah, I've cataloged the entire fucking sky, and now I can do something called astrometry, where by observing where Mars is at my location relative to the stars, and observing where Mars is at a different location relative to the stars, I can say, okay, it's in front of this particular star. Now, from my spot, it's in front of a different particular star. I know that these two stars are a certain angle of separation between each other.
Yep.
Therefore, I have a known value.
All right, there you go. You know the positions. You don't know the distances.
Oh, for fuck's sake.
You have to. Wait a second. Have you ever been in you've been in a planetarium, I'm assuming. You've been in one before.
I'm not where I'm going with this.
Okay, wait a second. You've been in one before, right?
Uh-huh.
Okay. So they're projecting these stars and constellations and things from an Earth standpoint onto a domed ceiling, right? And these angles are there, and they're depicting these stars that are supposedly vast distances away or whatever. But in reality, what we're seeing, even though we're seeing those same angles, we're seeing those same simulated stars as you would see in the night sky. They're only about 14 feet above you.
Cool.
So wait a second. So what I'm saying is that your angles and positions do not determine that, and none of that will tell me how tall the astronomer that's running the planetarium is. None of that will tell me that.
Would you?
Not at all. No matter how many times the fucking stars move around inside the planetarium, never will any of those values give me the height of the guy running the projector. Not one of them. So what I'm saying is that, so what? You see stars in the sky, and you see another light in the sky that moves along. How do you know what is that? How does that give you distance?
The movement of the stars.
But how does that give you distance?
I'm going to move on from this subject.
But here's the thing. There again, it's based in assumptions.
Cool.
It has to be.
I'm glad you think that. Can we move on?
It's not a think. It's not a thing.
It is a thing.
You are claiming that by looking at the position of lights in the sky, you're claiming that by looking at the position of lights in the sky, somehow looking at the difference in degrees at which I'm looking at, which we can agree that small objects close up or large objects far away, they're going to yield the same fucking results. So it's just an angle, and we're determining a position. That's all. It still doesn't give us a size. It doesn't give us a distance of any of the objects that we're talking about, much less any of the ones that are even closer to us.
Cool. I will go ahead and concede that astrometry does not work, even though it does. So I'm going to move on.
Well, the only way it works is with assumed values.
Except they're not assumed. You can directly.
Well, wait a second. Where is the proof of that distance or those sizes?
I'll tell you what. Let's do this. I will go ahead and either drive to your location or you drive to mine. We will measure the distance between the two stars and their position in the sky. We will then compare that to the value within astrometry.
Oh, I'm not going to doubt that they are going to appear at different angles.
That's what we've used.
It doesn't tell me that. Hold on a second. So hold on. That doesn't. Wait a. No, that's like. So I see some lights in the sky, and I see if I go over here, that light position changes. And if I go over here, that light position changes. That doesn't tell me how the fuck far away they are. It doesn't tell me how far apart they are.
What?
Because like I said,
cool.
You can take two objects that are very large.
I'm moving on.
You can take two objects that are very large, place them very far apart, very far away from each other, and get the same angle as you can from two smaller objects further away from each other. All you're getting is a position, and I'm not doubting that you can position. I'm not doubting that you can position stars in the sky. That's absolute. Yes, we use sextants. They use sextants for navigation. They use sextants for navigation, right?
Again, I'm moving on. Why?
Well, no, I want to finish this. I absolutely want to finish this because this is the crux. This is the crux of the heliocentric model. This is the crux of it. That we are rotating around some ball of fucking gas burning or fusion hydrogen, whatever the fuck, that's some magnificent, almost 1 million miles in fucking diameter.
Cool.
Now, this is the claim.
Cool.
And you have to go, all right, wait a second. How do you know these values? It's a legitimate question.
Yeah, but if you don't understand the answer, what good is
Well,
it?
I'm trying to understand the answer. And
No,
the
you're
answer
not.
you gave
No, you're
me,
not.
hold on, the
You're
answer
bringing up
you gave me,
motion when
the
motion is not
answer
a
you gave
factor.
me
You're
was
bringing
that
up
by
distance of
finding,
stars when distance is not a factor. You're bringing up angular size of stars when angular size of stars is not a factor.
well, then why are we using,
fusion
why
is
are
not
we
a
using
factor.
stars
You're
at all
bringing
then?
up planetariums.
Red,
Planetariums are not a factor.
red, why are we using stars at all then? We're trying to determine the
Because
distance and
astrometry
size of it.
works. Because
Wait
astrometry
a second.
works.
So somehow by calculating the position of lights in the sky, this is somehow going to tell me the distance and size of another object in the sky.
Yeah, because the position of the stars is known.
How?
I've
What known
explained it
value does that give
times,
you?
but apparently you don't understand
But
it.
wait a second. What known value does that give you?
That gives me the parallax angle, which is the point. Our goal during this trip
We
was
just already said that angle is not dependent on any distance.
correct. So
All
that
right. So then
angle
what
is
then
most
how could that possibly how could that possibly
Exactly. I'm glad that we agree that the
well then
angle
how
we
could
got
that
is
possibly
not
give you
dependent
any
on
information?
stars.
How
Good
could that
job. We
possibly
figured
give
it
you
out.
any information?
I was starting to lose faith in you, but you figured it out in the end.
All
I'm
right.
really proud of
So
you. So
great. Then let's go with that. Let's go with that. Let's go with that, Red. How does that if you don't know how far away those things are?
Able to figuring out step one of this shit show because we got about 12 more steps. Holy fuck, it's gonna be a bumpy ride.
No, it's not going to be a bumpy ride at all. It's not going to be a bumpy ride at all.
Judging by the
I'm on limited time as well.
Hard with it, it's going to be a very bumpy ride.
Okay, so
it'll be like driving down a dirt road in a Cadillac with broken suspension. It's going to be bumpy as fuck. So
okay, so can we get back on topic?
Oh, believe me.
Okay, good. So this is what you explained to me, and tell me if I'm wrong. You told me that by marking and noting the positions of stars in the night sky.
Astrometry. Yes.
Okay. Right. Great. Yeah. You use the sextant to do these things too. There's been charts and all kinds of shit. Very predictable. Okay, great. So what is it about knowing that this star is here and that star is there, and they're so many degrees away from each other when I look at them from my position? How is that going to tell you anything that would be useful in the calculation of the distance or size of the sun?
Okay.
What information there by knowing that this star is here and this star is here? Oh, and here's another object that passes through here, another predictable object like Mars, and we predicted it went here. Okay, like that. Okay, great. That's cool. That's great. Another thing I still don't know the size or the distance of, but we're going to go ahead. We're going to go ahead, and I know where these things are at. I know how many angles are degrees there are between the two objects, and I saw this other object fly through here. Okay, really cool. Right. So now, what about that information is going to be useful in the calculation of the size or distance of the sun?
The same way that it was useful with my parallax measurement of the International Space Station.
Would it not mean this? Well, wait a second. You had known values there. Yeah. We don't have any known values. We don't have any known values. You knew the size of the space station. You knew the approximated altitude. Everything.
No,
right?
I didn't. No. Hang on. We did this completely independent of NASA.
Okay. All right.
We did this completely independent of any outside influence. My only point in bringing that up was to show that our answers converged on the same answer.
Great. Now explain to me how the positions
Hang on. We did our observation separately, as in Astrometry did his
great. Listen, I'm all happy about your space station thing, Red. I really am. I think your space station thing is great.
Determined was that the actual process, the same exact process that we use for Mars, worked with the International Space Station.
What known value did you have, though? Hold on, wait a second. What known values did you use in your calculations? Did you go? Hold on a second. Did you give it any?
We went ahead and applied it. It
Wait a
worked
second.
out perfectly.
Did you use known values?
Yeah, the position
Okay,
of the
great,
fucking star.
great. That's all I need. You use known values.
Yeah,
Now,
position of the
what
star.
known values are used when using parallax to determine the size and distance of the sun? What known values, other than the positions of other lights in the sky, those are going to tell you a size or a distance? You can compare them to that because of the minutes of angle that change. That's
All
going
right,
to tell you size or distance. How?
I'm
How
going
in
to
the
try this
fuck?
in one swoop. I'm going to try this in one swoop. So I'm going to make you this deal. I am going to explain it from start to finish. And what I would like for you to do is to just shut up and let me get through it.
All right, we're going to let you
are
go. We're going
able
to
to
let you do
that-
it. You do it. You go
If
for
you
it.
are able to do that, we should be good to go.
You go ahead. You spout it out.
Where's your camera, dude?
What's that?
Where's your camera, dude?
My camera, dude? My camera's right there. I'm getting ready to hit a bong.
You don't want to show a bong hit on camera? Okay, dude.
No, I don't want you to see it. No, I usually hit it on bong, but I was worried about you rebroadcasting. I was being courteous to you, but if you don't mind, I don't mind.
No, I really don't give a shit. Anyway,
All right, cool.
All right, cool. So what we're going to do is this process is by cool hard logic. We did that before. So I'm going to go ahead and skip ahead from the original point, which we already got our parallax measurement. Can you share my screens, please? I'm sharing it right now. Let me know when it's up.
It's up there.
Perfect. Okay. Now we went ahead and
here. We don't fuck around here, Red.
I'm happy to hear that. Moving on. So we did our observation during opposition. That's when the sun appears to be the largest in the sky. So basically the largest angular size. And as you know, the closer it is, the bigger it is, blah, blah. So we try to make it so that it was closest. It makes the observation easier. So if we know the distance to Mars, and we know,
wait.
Fuck's sake. Okay.
No, not for fuck's sake. If we know the distance, all right. Well, okay.
Already here.
I mean, you're already with assumptions. We know the distance to Mars.
Assumption. Jesus fucking Christ. Okay.
Yes,
I tried. I fucking tried. My
well,
audience.
wait a second. No, go ahead. I'm sorry. Look, I'll even mute my fucking mic. But we said if we know the distance to Mars,
we do.
How do we know that?
Because parallax works whether you like it or not. God damn. Gonna have to put a poll up on my channel whether or not I should even continue on with this fucking point. Anyway, we're gonna try this one more time because I'm a nice guy. So let's see. Share my screen because I can see you yapping away, so I know you're not going to actually listen to this, but we'll try it anyway. So anyway, with the distance of Mars known and the angular size known because we directly measured it, we can then figure out the actual size of Mars, as in the actual diameter in miles or kilometers or whatever, because it's all following an equation of the law of perspective. Law of perspective being alpha equals 2 times the arctan of g over 2r. Alpha is the angular size of an object. G is the actual size of the object. R is the distance to that object. You can rearrange that equation to find g, which is the actual size of the object. The actual size of the object allows us to figure out how big Mars is at opposition through all of these different points, as you can see on this graph. These are the dates of oppositions. These are dates in which the measurements were taken, which means we have an observation here, we have an observation here, and so on. So if we are able to draw this out, let's just look at an image of the solar system. Mars will appear the smallest when it's at this part relative to our orbit. Mars will appear the biggest where it's over here relative to our orbit. So if we're able to take this into account, then we are able to make a simple mathematical equation to find our distance to the sun with the use of Kepler's third law. We know Kepler's third law because we can compare orbital times between the International Space Station, which we measured, and a geostationary satellite, which we also measured. So if I'm able to go forward here in time, this is where I can bring up my Solfax. You can see that diagram, this diagram, which I'll bring up right here, you can see 2A, 2R, D1, D2. These are the values that we are working with. Now, because I was able to know the actual size of Mars, I can rearrange the angular size equation to figure out the actual distance to Mars at this point, D2, and this point, D1. I know their actual distances because of the law of perspective. So that gives us this equation. The equation being that we have 2A equals 2R plus S plus L, which is D1 and D2, which is, at its furthest point, it's 101,506,506.8 kilometers, and D1, which is, or the closer distance, I should say, is 55,805,283.63 kilometers. Now we have 2 times the product, or the solution of 1.524R, which we got via Kepler's third law, which again, we can verify by comparing orbital times between the space station and a geostationary satellite. We can then put this equation together and rearrange it to find R. And when we do, we get 1.048R equals 157,311,790.43. Rearrange to find R, which again, on our diagram, rearrange to find R is going to be a distance between Earth and the sun, which means that after all is said and done, we get a value of 106,670.25 kilometers, aka roughly 93 million miles. This was using observations that we did ourselves when we're talking about the actual parallax of Mars, the actual angular size of Mars, the confirmation of Kepler's third law, which you can do between the space station and a geostationary satellite, putting all of these values together with historical data of the angular size measurement of Mars at different times during opposition, we can figure out a distance to the sun because we can literally build a model mathematically of the solar system and figure it out from there. It's a beautiful thing. I just want you to know that you're muted, but I didn't bother telling you because I've been enjoying the silence.
I can see if you were enjoying the silence. If you're enjoying the silence, I can understand why you would be, because this, again, you premised the entire thing with an assumption.
Cool.
Okay? You did. You prefaced the entire thing with an assumption and then used that assumption to verify another assumption. Cool. And the way you did that was, if we know the size of Mars, well, you don't know the size of Mars.
Yeah, we do.
Second, no, how would you possibly know
the size of Mars with its known distance, which we got via parallax? We can find its actual.
You can't. Size. No, listen, I'm calling bullshit on your parallax telling a distance.
Arcane of G over 2R.
There's another part of this that. Hold on a second. I let you yammer on. It's my turn now. Okay.
You're wrong, but go
ahead.
All
right. I don't give a fuck what you think if I'm wrong or not. What I'm telling you doesn't make any kind of logical sense whatsoever. The shit you're saying makes no logical sense whatsoever. You're telling me that based off an assumption,
nope,
knowing the size, would you parallax? It's like gravity. That's all you say is parallax. Parallax don't mean shit, because as we already told and demonstrated, that parallax will give the same results of small objects close up as large objects far away. So there again, it was based on an assumption.
Nope.
Now, second thing, well, you can say nope all you want to. It was based on an assumption.
No,
Somebody assumed the distance to these various objects, because you cannot measure the size and distance of an object without a frame of reference. And I'm sorry, the position of lights in the sky are not frames of reference unless you know their distance away.
I guess you're fucked, sailors. I guess you're fucked.
Oh, I'm not saying that you can't use a sextant. I'm telling you that these phenomenal distances that are being calculated are calculated based on assumptions. That's all there is to it. That's all there is to it, because parallax doesn't really tell you anything. Parallax will only tell you something as far as a position. It's not going to tell you what the size or distance of something is. Not at all.
Cool. Well, it's clear you don't understand what the fuck I just explained. So can we move on?
Yeah, I don't, because you explained, you started it right off with.
Glad we had that
if we know,
and that's fine.
You started it right off with, if we know the distance to Mars. And I'm saying you don't know the distance of Mars. Nobody does. A dusty red ball that shines brighter than many stars in the night sky, when it's twice as far or more away from the sun than we are, that makes zero fucking sense to begin with.
Yeah, it makes zero sense to you.
Well, doesn't make sense to anybody. What reflective properties does a fucking dusty ball have? None. Especially when it's twice as far away. That makes zero sense. But that's an assumption. That's an assumption.
If you're at the beach, you can't see shit now. Sorry, guys.
Wait a second. That beach isn't going to reflect millions of miles across the fucking space and shit. It's not going to. Okay.
Desert.
Especially with that dim of light. You got to figure how far it is. We're 8.5 light minutes supposedly from the sun. How fucking far away is Mars?
Made of Vanta
black. You've got the inverse square law of light. That's definitely not going to. It's not going to intensify the more distance you add to it. But nevertheless, back to square one. Back to square one was the assumption of a distance to an object. That was an assumption to a distance of an object that was used to calculate other distances.
Dude, you brought
there again. If one of your things is a
equation of perspective, you're like, nah, fuck that. We don't need this. The very moment I utilize it to debunk your bullshit, and now you
didn't debunk anything. All you did was you said, if we
like
know, how does you cannot explain to me how plotting the positions of stars in the sky are going to tell you the distance and size of an object that you have no frame of reference to give to it. You have no frame of reference.
I have literally told you the frame of reference like a million times right now, and I'm sick of this subject.
Yeah, I know. You keep saying this word, parallax. I know what parallax is. I'm a long-range shooter, bro. I know exactly what it is. And the effect is the same close-up as it is far away.
Stop being ignorant about it. If you
I'm not being ignorant about it at all.
Oh, shit, you're not.
No, you told me that by knowing where the positions of stars are at in the sky, and the position of another object that I don't know the size or distance of, moving through them or past them or some other shit, is going to tell me the size and distance of something else.
All right,
that makes zero fucking sense. That's like going, I'm going to know how deep my swimming pool is by watching how often the mail truck comes by.
Dude,
it's that connected.
Obviously, you're not going to understand this shit. So I'm moving on. Why doesn't the sun change throughout the day?
It does.
It
changes throughout the season. Even I've seen it different. I've seen it appear drastically different sizes at different times of day, at different times of year, and none of it dependent on anything other than the way it's being viewed. That's all.
Do you have any evidence whatsoever to show the sun changing in angular size?
Yes, I've seen it. I've got a video. I'm in fact getting ready to get off of here, and it's because I've been on here for 2 hours now.
What is the video that you are referring to?
There's one with the fade out. Let me see if I can find it real quick.
Yeah, it fades out, as in it wasn't using a solar filter?
Yeah, it was.
It was. Oh, I got it.
It was, and it did change. You see it get slightly smaller, and then it's no longer visible. And not because it went onto the horizon either. It was because it was too far away for the light to reach.
I'm going to make a bet here. I'm going to bet that whatever video that you are showing either does not have a solar filter or it wasn't zoomed in at all. I'm going to
Okay,
make that
well,
right now. Let's see.
as I've said, I've been on here 2 hours.
Hey guys, Rob Skiba here. So,
Of course, Rob Skiba. I know exactly what video you're referring to.
Oh no, that was just something that came up on another list. It was, I tapped my phone. I was in another search, and that came up. I like Rob Skiba. I like Rob Skiba.
Skiba's in your list. Oh dear God.
Yeah, you would say that because he's a threat to this fantasy that you all have of an Earth ball
He was
flying through a fucking void and all that other shit.
I've challenged him to a debate multiple times, and that dude fucked off faster than the speed of sound. I'll tell you.
Yeah, I could imagine. You're very condescending. I would too, but I'm able to deal with people. I'm able to deal with people like that because you've still failed to explain how plotting the positions of lights in the sky is going to tell you the size and distance of any fucking thing.
No, you just fail to understand it. That's not my problem.
Won't. No, it's not about it. And yeah, you're right. I don't understand it. I will not stand under it.
Absolutely.
I will not stand under it. You know why? Because it doesn't make sense. It's black magic. It's mind wizardry. It's mind wizardry. That's all it is.
Just intellectually incapable of understanding it.
Well, you can believe whatever you like. I don't care. In your opinion of it, your opinion is of no bearing to me. I don't care. You believe that you live on a ball that's magically, and that you can just explain it away by using the word gravity or parallax. Okay, I understand what parallax is. I could take two objects and put them very far away from each other at a very far distance, and I'll get the same fucking angle as I will two objects that are farther away at a closer distance. I will get the same fucking results. That's not going to tell me size or distance. I have to have a known goddamn value in order to calculate any of that shit. And you prefaced your entire thing with, if we know the size of Mars, well, there again, if a bullfrog had wings, if a bullfrog didn't have wings, it wouldn't bump its ass all the time when it jumped. Okay. Angular size of a point of light, angular size of a point of fucking light in the sky. You're shitting me. You're absolutely shitting me. You do not know the size or distance of Mars. Mars is a light in the sky. You don't know the size or distance of any of these objects based on anything other than an initial assumption. And that is my point. The second thing that you still have not been able to prove is that you cannot have, listen, we're right at basics. Fuck all the rest of it. Yeah, we're right at basics.
Know that Mars is not a point of light. Go ahead. Share
it isn't. How come I see a red? Hold on a second. How come when I look at it? Wait a second. Hey, when I see it in the sky, Red, when I see it in the sky, I see a red star. That's how I'm drawn to it. That's how I know which one it is. I see a red star in the night sky, and I am able to know that is Mars. Absolutely, that is Mars. Now,
waiting for you to show it, dude.
Show what? You can go out in the night sky and look at it. You can go out in the night sky and see it. Can you or can you not see? Can you or can you not see fucking Mars in the night sky with the naked eye?
Share the screen.
Can you or can you not see Mars in the night fucking sky with your naked eye?
And get your fucking answer.
I'm asking you. It's a simple yes or no. It doesn't require the sharing of a screen. Can you or can you not?
No, you've just been debunked. I told you.
No, I've not been debunked. You haven't even answered my question. I'll share your fucking screen as soon.
Share it right now. Fucking do it. I dare you. I double dog.
Okay, sure. What are you going to show me? A cartoon?
Cool.
A cartoon. It is a fucking cartoon.
He took that observation directly, dumbass. So not
observation of what?
When you think you know perspective, you don't
dude, that is a fucking cartoon. What is this white ring? What is this white ring around it? Is that 1% atmosphere that they fly a fucking helicopter in?
He found that with his telescope. Oh, yeah.
Red.
Go ahead.
Red. No, I don't believe he did film that with his telescope. That looks like a computer-generated fucking bullshit to me because I've looked at Mars through a telescope. And it just looks like a red star.
He will make the observation in front of you, and then what will you say?
Red. Can you or can you not see Mars in the night sky with the naked eye?
Yeah, and with the telescope.
Okay. Don't go any further.
Nope.
So you can see it. Shush.
No.
You can see it. Why can you see it? Why can you see it? Why can you see
it? That I can see this thing and it's not a light in the sky, but there's actually surface features. And the fact that
hold on a second. When you look at Mars with the naked eye, how are you able to distinguish that that's Mars? What is it?
I can look at it through a telescope. And
I'm not talking about a telescope. I can see it with my naked eye. Just a second. Let's get beyond this. Hold on a second.
Fuck your world up. That's why you don't want to measure the
No, it's not. You're going on beyond. We'll go with a telescope here in just a fucking minute.
Actual observations. Thank you.
Just a moment.
Captain Obvious.
Hold on.
Anything else you would like to enlighten us with?
Yes, I would if you'd shut your goddamn pie hole long enough for me to finish.
Oh, I'm going to keep you on for 3 hours, bro. Let's see how long I can keep you wound up.
It's not going to be much longer, I can tell you that. But I can tell you this. How long
I'm going to bet 3 hours, so I got 50 minutes on the clock. Let's do this shit.
No, okay. So, what? How are you going to do that? By keep interrupting me?
No, I'm going to keep challenging you to show the screen, and then you being a total bitch boy and not doing it.
All right. So there you go, right with the ad hominems again. So what I'm trying to ask you
tries to call me a fucking liar and said that
I'm not calling you a liar. I didn't call you a liar. I said that fucking footage is goddamn computer generated shit.
Which means you're calling the guy who took it a liar, you fucking dumbass.
Okay. All right. And well, then so be it. So be it. If the shoe fits, lace that fucker up, man.
Yeah, except the shoe doesn't fit.
It does fit. So anyway, back to my initial question before you started spiraling. Let me get the initial question out.
Yeah. So Astrometry Live takes an image with a telescope and you call it CGI. Tell me again about your expertise. I'm curious.
Okay. So back to my initial question. I see you're still spiraling. You can stop spiraling now. There's no need for it.
Like the Mars? You mean like Mars was in that video that you refused to show, right?
Okay. So my initial question was this: you can see Mars in the night sky with the naked eye, correct?
Duh, that's why we have a picture.
Correct, right? Yes, it didn't require duh. You don't have to go there. Don't go to third grade. We're staying growing up here.
Dude, we've been
you keep wanting to devolve to that. No. You keep trying to devolve to that. So if I can see Mars in the night sky, how is it that I see it? What is it that I see? I see a what? A red light, pretty much, right? Isn't that what I see?
Naked eye, yeah.
Yeah, with the naked eye. Yes. With the naked eye, I am seeing this light, and it's red, and that's how I know that it's Mars, because it's the red star up there. That's the one that I can see. The other, hold on a second. I look here and I see a white star, blue star, white star. There's a red one. That red one right there. That one red point of light right there, that I know is Mars, right? Okay. So, all right. So I can see it in the night sky, and with the naked eye, it appears as another star, but of a different color. But something else that we notice about it is that it moves in these different directions. Now, when I do zoom in on it with a telescope at home, or even with binoculars or any other thing like that, it does seem to get brighter, because it would have to because of the inverse square of light. It would have to get brighter as my view to it gets closer and closer. And so when I see this, which is in complete direct contrast to anything I've ever observed, the only time I ever see this bullshit is when it's from somebody at the observatory or some other shit like that. And I can't understand why they're getting around this brightness effect. But in any case, I see a red star in the sky. Now, you said that I don't see that, but we just agreed that is something, that's exactly what we see. And then we zoom in on it with the telescope. Now, the image that you had there is not what I see. That's not what I see. Hold on. When I look at it, how come I don't see that? The image I'm
currently screen sharing that you're refusing to show, right?
We showed it. The cartoon? You want the cartoon back? Let's have the cartoon back. Let's have the cartoon back. So there it is. There's your cartoon. There it is. And it's going around. Why is it stopped shining?
Stop shining? It's a telescope view showing the entire planet. And as you can see,
I understand that. So why didn't it get brighter as you zoomed in on it? Shouldn't, if it's shining as a red bright star in the sky with my naked eye, Surely, as I zoom in on it, it should become brighter.
Actually, when you zoom in on things, they actually get slightly darker. And and also on top of that, did you know that cameras have brightness control?
So then if I could take a telescope and actually zoom in on the sun and it would dim down so it wouldn't hurt my eyes, right?
That's called brightness control. And yes, cameras do that.
Yeah. Dude, that is a cartoon.
No,
okay, I'm sorry.
And he will do it in front of you. And if he
does, good. He can come here and do it in front of me. He can come here and do it in front of me. We still don't. We still. Hold on a second. Hold on. You still have not figured there's this size and distance thing, and this is the whole crux of it all. Is that the shit is based off of
on nothing.
I'm calling it liars based on the fact that there are many fucking liars trying to support this nonsense, fucking helio-nonsensical bullshit.
How about this? I will go ahead and do this for you, and I'll do this for your audience as well. You come down and you will do the observation. And if what you observe...
Observation of what? That the lights in the sky change position? No, yes, I agree. I agree with that.
We will make your version of that. And if it turns out that we were not full of shit the entire time, will you apologize on camera?
Well, sure. Okay, absolutely. But I'm not disagreeing that the positions of the stars change relative to my position on my viewing platform.
I will pay for your travel. I will pay for your hotel. Get your ass down here. Let's do the observation. And when Mars looks that way in the telescope with your own observation, you will apologize to Astronomy Live, correct?
Oh, sure. Absolutely.
All right, and you will say that your original claim of CGI was bullshit because you didn't know what you were talking about.
Yes, I would. Well, I will say that I was wrong in that respect. If I can see that exact same image that we're seeing there, if I wait a second, let's set
this up. Let's set up the travel dates.
And then I'll punch myself in the face. How's that sound? How about that? Right? I'll punch myself in the face too. That sound good? That sound good? All right.
What in the face?
So now you still have failed to, and I don't mean that you're a failure. I'm saying that that what I've asked is still not really been answered.
Yeah, when you don't listen to the answer, that tends to happen.
No, the answer that you gave me was that by looking at where 2 points of light or 3 points of light are in the night sky.
I guess I should rephrase that. By not understanding the answer, that's bound to happen. Okay, my apologies. Continue.
Okay, wait a second. Hold on. I would love to know how that's going. Other than a position, I'm sure that it can give you a position, but I don't see how in the hell it's ever going to give you the size and distance of another object without any known values.
Mars is what we were measuring directly with the angular
size. But you went with a known. Hold on. Did you or did you not start with a known or assumed value?
It was known, not assumed.
What was the known value?
Astrometry, the distance.
Well, no. What was the known value? What was the known value?
Distance between the two
stars. Astrometry.
Cool. Yes.
Yeah. No, that doesn't mean anything.
Doesn't mean anything to you because
it doesn't mean anything to anyone.
No, it means a lot to.
It's not going to tell you. Listen. Looking at two lights in the sky.
Astronomers use it every single day, dude.
Well, and they're using assumed values to get to the values that they have. Yes, they are, because right off the bat, an assumed value was used.
Works. It's not assumed. It
is.
Works.
Well, how do you? No, it doesn't.
Yes, it does.
Listen, because a close object. Listen, a close object. A close object.
It works, dude, because it's used every single day, and we'll even demonstrate it right in front of you.
Well, that's well and good. You have to use no known values because you don't have any.
And the separation between the stars is a known value.
Well, how do you know wait a second. All you know is the angle. You don't know the distance.
Given the
you don't know. Wait a second. No, you don't know the distance between those stars. You only know the angle between them. From your perspective, that's the only thing you know.
The angle between the stars. Congratulations. What? We only want the angle between the stars. We don't need
the distance. So we can agree that two little lights close up and far apart will yield the same angular distance as they would if they were large objects very, very far away, right?
The word you're looking for is separation, not distance.
Yeah.
Not talking about distances.
Okay. Well, that's important, don't you think? Because if that distance You see,
No,
because
the distance to stars is irrelevant. Every time you bring up distances, you're bringing up a straw man.
well, wait a second. No, I'm not, because
Yes,
that
you
angle
are.
between them. What difference does it make? What angle there is between them then?
All right,
What
got
would
it.
that and what would that have
Yeah,
to
we're
do with
already past
anything?
that.
I mean, if I could measure that same angle, for instance, I'm going to bring the planetarium in. Okay.
Should I bring up my
And
my
the thing is with it, well, I'm getting ready. We got like 10 minutes is what we got left here
10 minutes?
because I have things that I need to do. So if I'm in the planetarium and I measure the angular difference between two stars inside the planetarium, and then go outside and I find the same distance or the same angle between those same two stars outside, I got that same distance. I got that same angular, right? I got that same angle. It has to represent an accurate representation of the stars. So it's the same inside the planetarium as it is outside the planetarium. And in one case, it's only 14 feet above me. And in the other case, it's way, way high above me. So how do I know that the stars I'm seeing, how close to me they actually are? So that angle between them, if that angle between them is used to measure a distance,
the distance,
right? Because that's the only, other than knowing the angle, the only useful thing there would be a distance.
We're not making the measurement in a planetarium, first of all. And the second of all, we are.
Did you miss the point? Did you miss the point that the results would be the same fucking results?
No, they
would be the same results inside the planetarium as they would be outside under the real stars. Yes, they would.
No, they fucking wouldn't be. By you
then
saying
it's not an accurate representation of the sky, is it?
By you
is
saying
it an accurate representation of the sky? It's just scaled down. It's scaled down, right? It's a scaled down
representation of parallax, dude.
It's a scaled down version of what we see outside, isn't it?
It's scaled down to the point where you're being completely irrelevant with the actual distances that we're talking about when it comes to Mars.
No, I'm not. No, I'm not. Because let's hold on a second. Hold on. Let's look at it. Let's look at it again. Let's say we've got star A. We're inside the planetarium.
And we had a star here and a star here within the planetarium. And let's say someone's head was to eclipse a certain star within the planetarium. I would be able to measure using an actual piece of
equipment. Yeah, because you know the known value of the head
between one star in that planetarium and another star within that planetarium. If I got that and I'm able to use that as my standard of measurement when observing angles, and I was able to observe that head for two different spots on the fucking floor, I would be able to get a parallax measurement.
Well, wait a second. You have a known. You have a known fucking value. You have a known value. You know the size of the guy. And wait a second. No, you know the size of the guy's head and how far away he was when he went by.
I don't need to know the size of the guy's head. I only need to know his position.
What? Everybody's head is different? No. No. The size of the. There's your known value. There's your known value.
Every time you bring up size, you bring up a straw man. Every single time.
No, I'm not bringing up a straw man. That has everything to do with perspective.
Jesus fucking Christ. It's like if I try to explain that
it has everything to do with perspective, Red.
Your position in the sky, but you can't even understand that.
Wait a second. Yeah, what you're not getting is this. Hold on. Is a planetarium a pretty accurate representation of the night sky? Yes or no?
Not in terms of doing observations.
Wait a second. It isn't.
No.
Really?
Correct.
So you're telling me that the angle that they use in scale of different objects in the sky are not the same as what we see outside?
No. You want to know why?
Really? Why?
Why? Because the planetarium is simulating the sky from a single observer.
Okay. Well, no, not really. Because if you're sitting, because you're getting a different perspective regardless of where, depending on where you are in the planetarium.
Parallax, we had two different observers spaced apart by thousands of miles, dude. That
so what?
Simulated within a planetarium, you dumbass.
Well, wait. Okay. Red, you have used your last ad hominem. Goodbye. Okay. As I said, we're going to have to cut this out anyways at 7:30. There is no way you're going to calculate the size and distance of an object at all using 2 points of light with no known values other than that they're this angle and this angle from each other. Because as I tried to point out with the planetarium analogy, was that scaled down representation of what we see in the night sky, those stars are still the same angle away from each other in that planetarium as they appear in the night sky. This is why it's a simulation, because it's scaled down. Now, has the distance between those 2 points of light different? Yes, absolutely. But the angle is still the same. Without a known size, without a known distance, or something to compare it to, you can say parallax all the fuck you want to. I understand what parallax is. It's still not going to tell you the size and distance of an object without something with a frame of reference. You have to have a known value. And as you see in his example, when he said, if we know the size of Mars, and that was my, okay, how do you know the size of Mars? I say Mars is the size of a fucking Volkswagen. Prove me wrong. You don't have any frame of reference to go by. It's a point of light you see in the sky. Yes, you can look at it with a telescope. It appears to be round. Do you see what he showed? No, none of you ever see that. You see a red fucking ball, a red circle is basically that you assume is a ball because they told you it was a ball. But none of that tells you how far away or how big it is. You'd have to know how big it is in order to calculate how far away it is. You'd have to know how far away it is in order to calculate how big it is. Or you would have to have the known values of some other object. And what other object would there be that you have known values of? You don't have anything. The calculation of the distance of the sun initially was based on his thing that he said parallax. And they said, well, we watched Venus go by the sun and we watched it from two different locations. And, you know, we determined this because after all, since Venus is about the same size as Earth, and it's like, stop. How do you know Venus is the same size as Earth? You don't. That's assumed. So any calculation you make that derives itself from any assumed value is an assumption. And you have to think how far off some of these calculations could be when, for instance, they want to calculate in the speed of light, which is not a constant. This is an agreed upon number based on different readings from different people. They got together, and I think it was Bern, Switzerland, at a physics convention, and they agreed upon a speed of light based on an average. But these formulas rely on using it as a constant when it's not shown as a constant. So my biggest contention is the fact that there's so much assumption used, treated as fact. They use this idea of parallax, and the other magic word is gravity. Gravity is the other magic fucking word. I really wish he hadn't gone to the ad hominem. These people do seem to get very upset very easily. And they end up, when you ask pertinent questions and pin them in a corner, oh, you just don't understand. Well, tell me, how is that I look at two different angles of lights in the sky and I have no known values for them other than how far apart they seem to be angularly from where I'm at? How does something else passing by? I don't know what the distance or size of that fucking thing is either. It could be close up. It could be far away. It could be very big and far away. It could be very small and close up. I have no fucking way. Nothing to frame of reference to tell by. Nothing at all. So they make assumptions. And the entire thing is based off of those assumptions. And then the biggest go-to, if they can't, gravity. Well, what is gravity? Well, it's a force. Well, it doesn't appear to be a force because hot air rises and butterflies float along. And if it was a force, it'd be slamming everything to the fucking ground, right? We're supposed to be holding everything against the spin and flying through space and everything. That's a hell of a fucking force. Holds all this water while we're spinning, but I can take a straw with the weak lungs and drink it through a straw. That makes absolutely zero sense. So what they want to do is they conflate an effect and want to claim that the effect is the cause. Well, the effect is not the cause. The effect cannot be the cause. Yes, I agree. Things drop to the floor. There is a downward vector. I agree. Okay? That's absolute. What causes it? Personally, I think it's an electrostatic function based on things that I've looked at. The rest of it is what? Because of fucking jawbreaker Earth that has a molten nickel iron core with magnets and really? That just makes everything stick? The reality is nothing needs to stick because nothing's fucking moving, man. We're stationary. There's no need to be stuck. There's just a downward attraction. The rest of it's all density and buoyancy. Now, as far as gravity, then they want to ascribe an effect to other objects. How? By making up this bullshit about mass attracting mass, but there's no evidence of that. The only thing they point to as evidence is some kind of cockamamie fucking experiments that this guy Cavendish did, where he hung some cannonballs in his fucking shed and watched them with a telescope or some dumb shit like that. And it's like, get the fuck out of here with that. Mass attracts mass. There's no proof of that dumb shit at all, but they have to claim it in order for their gravity thing, for them to be able to place this on other celestial objects that they don't know what they fucking are either. And so they assume that they have these effects upon them for some reason or another. We also have people that want to determine that the shape of the Earth is wholly dependent on what the shape of things in the sky appear to be. That makes sense. Every time I'm trying to check what kind of let's see, is my floor level or not? How can I tell? I know. I'll look up at the fucking lights in the ceiling. Well, since they're not level, I guess my floor is not level. It must be round, bulb shaped, because the lights in my fucking room are bulb shaped. That makes zero sense. And they're again based on assumptions. Oh, those are large lumps of rock that formed together and decided to be balls and float around each other and shit. And yes, they have this attraction to them just like we do. And it's like, well, this is all fucking assumption. You are taking an effect and ascribing it as a function that happens everywhere with zero proof of any of it. Oh, well, we have these mathematics and shit. I mean, secondly, the atmospheric pressure being maintained in a near zero vacuum. These are NASA's numbers. These are from the Glen Allen Research Facility, man. These aren't mine. You wanted to ridicule me about these fucking numbers. These aren't mine. It says here that 10 to the negative 11 torr, which is what they say the atmospheric pressure or lack of pressure on the moon is like negative 2 billion psi, if there could be such a thing. But the bottom line is you're not going to have a gas pressure system of any kind next to a vacuum or a lower pressure system without containment, or else you risk it's going to happen. Equalization will take place. Equalization takes place all the time. We see this. When your beer goes flat, it's because of equalization. When you first crack open your fucking can of soda, psh, why is that? Because the pressure inside the can is greater than that outside of the fucking can. What? A high pressure system inside of a low pressure system requires the containment of the can. And once I breach that containment, psh, equalization takes place. There's no way around it. There's no way around it. So anyway, that's what we had here tonight. I think it was okay. But I did like to get that out there, that's assumptions, 99%. And if any part of your equation, any part of your method is built on assumption, then it's an assumption. Okay. Now I can see that Liz K over here is highly, highly triggered. That's all right, sweetheart. You'll be okay. Unclench your butthole, go in the corner, fart. You'll feel much better. Trust me, you will. It just amazes me oh, yes, yes, yes. But you're absolutely right. 14.7, right? And when even with like a rail car, you don't even have to go into the negatives. With the tanker rail car, they only took it to 3.8 and it crushed it in an instant. So we can apply those same things to in the opposite direction as well. If we were able to somehow keep that pressure at 14.7 inside the rail car and decrease it out here in the world, which of course would kill us, but if we did, it would cause the rail car to fucking explode because nature abhors a vacuum. It's real simple. So anyway, and where's Terry? Terry is out riding around. I'm going to get off of here and probably go watch his stream. I want to thank everybody for coming. I didn't really pay attention to the chat a whole lot. Sorry about that. The pressure cannot be the cause of the pressure. Sorry, Zerzooks. Pressure cannot be the cause of the pressure. The cause cannot be the effect. The cause cannot be the effect. Always remember that. Okay. So anyway, Lord loves a working man. Don't trust Whitey. See a doctor and get rid of it. Everybody, you have a wonderful evening on this motionless, flat earth. Go outside, enjoy the firmament. Enjoy it moving around you, giving you signs of the seasons and events. Enjoy those things. They're here for you. Y'all have a good night. Good night.